Hello, hi, namaskar everyone. My name is Dipendra and I welcome you all in this video where we'll be discussing all the formulae of your entire mathematics for your JEE 2026 April attempt. Mind you, what I've just said is we'll be revising all the formulae of your entire mathematics in this one revision session. Yes. So it's purely formula revision session, purely theory revision session, mostly the important formulae, the crucial ones. And yes, I'll be highlighting those ones specifically which are constantly repeated or asked by JEE. We'll be highlighting those, but yes, everything is equally important. So we'll be going through everything. And do remember, once this session gets over, you will get the PDF of all these formulae. This is a 200 pages PDF. It includes all the formulae of your entire JEE mathematics. So this 200 pages PDF will be shared on our WhatsApp channel, and to follow our WhatsApp channel you can scan this QR code and you can follow us. There we'll be sharing this entire PDF. I repeat, we'll be revising all the formulae in this session of this entire mathematics of all the chapters for your JEE April attempt, and the entire formula sheet will be shared with you on our WhatsApp channel. You can scan the QR code and follow us. With that, let us get started. Even if you have missed the QR code, you can see the link to our WhatsApp channel in the description of this video, from where you can follow us. Now, let us get started. We'll be discussing the formulae of calculus, algebra, trigonometry, vectors in 3D, and of course, coordinate geometry. Everything in a straightforward, crystal clear, detailed, comprehensive, and thorough manner. So with that, let us get started. Hello, hi, good morning, everyone. Just give me a quick update. Am I clearly audible and visible to all the participants? Can we get started? Here. If I begin with calculus, this is something decent and straightforward. You all are aware of the formulae of derivatives. If I simply ask you few ones which you may have forgotten or may have missed, ddx of a to the power x, it is a to the power x log a, and there you got to remember that these formulae lay the foundation for the formula of integration. So if you are good with these formulae, you are decently good with the formula of integration as well. Yes, that's great, Black Mystery, that's good, famous user Nitya Patel, Dubey, everyone, good to have you all here. From here, the next formula will be, I hope these all are very well understood by you all. Nothing much is needed to be explored or said here. You all know these very clearly. These are some really crucial ones because yes, in integration, these are very handy. If I could simply tell you this one, that when 1 upon under root over 1 minus x square is integrated, then it is sine inverse x plus c. And when you have this 1 upon 1 plus x square, when it is integrated, it is tan inverse x. And yes, if it is 1 upon a square plus x square, then its integration is 1 upon a tan inverse x upon a. I hope these basics you all are clearly aware of. Now from here, when I go ahead or move ahead, yes, there is something very crucial. We know the product formula for the derivatives. If f of x into g of x is given, we know the product formula. But what if there are more than two functions as a product we are given? Then what do we do? The idea is really simple here, students. Good morning, everyone. Good morning. Good to have you all. Let me just refresh this screen so that everybody becomes visible to me. I think there is some problem with my end on the screen. Let me just refresh it for a while and then we'll continue this discussion. Great. So good to have you all. I hope you remember this very clearly, that let's say three functions are given. Then differentiation. How do you do it? Take any function, differentiate it and keep other two as it is. Plus, take the second function, differentiate it and keep the other two as it is. Plus, take the third function, differentiate it and keep the other two as it is. Let's say four functions are there. The same logic applies. Derivative of first function, keep the other three functions as it is. Plus derivative of the second function into the other three functions as it is, and so on. So that's how you apply the product rule. And what about the quotient rule, students? I hope you all are very clearly aware. Denominator should be squared in the denominator only. Then denominator as it is, derivative of numerator, minus numerator as it is, derivative of the denominator. If you are aware of these basics, yes, they'll definitely help you highly or very much in your JEE examination. Now this is a short technique to differentiate implicit functions. Here, remember this, explicit functions means what? The functions where y and x can be separated. But if there is a function where you cannot segregate or you are not able to separate y and x, in that case, how do you differentiate it? Let's say this is a function of x and y, and this is what is needed to be differentiated. So you need to find its derivative, or technically dy by dx is what you're supposed to figure out. So one of the methods is you start differentiating it and you can get the answer. The second method is really interesting. You can directly write dy by dx with this short technique. What is that short technique? Students, pay attention to that part. The short technique is really simple and very interesting. It says you should differentiate this function partially with respect to x. So partially with respect to x means what? 2x, this 2xy. So with respect to x means what? It will be 2y, and y square will be treated as 0. Then divide this by derivative of this same function and now differentiate it partially with respect to y. So when you do that, partial derivative here with respect to y will make it 0. This of course is going to be with respect to y you're doing it. I hope you're understanding. I'm really sorry. Yes, it is 2x. It is 2y. Yes, great. So it should be what? 2x it is going to be, plus it is going to be 2y. Let me just cross check it once again. Here, the derivative of x square with respect to x is 2x. Here, it will be 2y. This will be 0. And in the denominator, this will become 0. This will become what? I hope you're understanding with respect to y. So it will be 2x and this will be 2y. And then don't forget to put a negative sign here. Don't forget to put a negative sign here. What we are clearly seeing is that this and this are getting cancelled. And finally, you are left with -1. So this really helps you in figuring out the derivative of implicit functions in a very quick manner. Rather than differentiating it and then adjusting it and then taking the common, that will take a lot of time. So yes, good to have you all. Navina, Deepak, Black Mystery, everyone, good to have you all. I hope you have understood this. So this is a short technique which you should keep in mind from here. Now, some trigonometric identities which are not only useful in differentiation but in integration as well. What are they? Pay attention to them. First of all, yes, sine 2x. We often use it in as 2 sin x cos x, and this one which is very highly and prominently loved by JEE. Which one, students? This one. The other version of this is this. I hope you all remember it very clearly. 1 plus cos 2x and 1 minus cos 2x. I hope I need not tell you 1 plus cos 2x can be attained from here. I hope you are clearly seeing it. It will be 2 cos square x, and whenever you see 1 minus cos 2x, it is always 2 sine square x, and this exactly lays the foundation for the other properties as well. For example, tan 2x. Now here, I hope there is no confusion on sine 2x. This version we need a lot in inverse trigonometric functions. When you deal with formulae, their transformation is needed, and to remember that, if you could see some pattern, then remember sine 2x is written as 2 tan x upon 1 plus tan square x. Cos 2x is 1 minus tan square x upon 1 plus tan square x. And if I divide this by this, I'll get tan 2x, which will be 2 tan x upon 1 minus tan square x. I hope everybody is listening and understanding. We can move ahead from here. Now, the second conclusion is this one, but I hope you are aware of this version of the formula of sine 3 theta. In JEE Mains as well as in advanced as well, direct questions, I'll show you the direct questions were asked based on this formula. So question was really simple. What they give you was that they gave you sine, let's say 50 degree into sine 10 degree into sine 70 degree. Now, if you relate it clearly with this formula, what do you see? Sine 60 minus 10, this is sine 50, sine 10 and sine 60 plus 10, that is sine 70. So remember that this formula is nothing. I repeat, sine 60 minus theta into sine 60 plus theta is always sine 3 theta by 4. Is always sine 3 theta by 4, which means sine 3 theta. Theta here is 10, so sine 3 theta will be 30 by 4. You know what is sine 30? That is 1 by 2 by 4 is 1 by 8, and the answer was direct 1 by 8. But if you could remember this identity, you could get the answer within 10 seconds. So I hope you will remember this version. We all know sine 3 theta is 3 sine theta minus 4 sine cube theta, which we often use in integration as well. In integration, you need this. But if you could remember this version, this will help you definitely in a very, very, very strong manner. Can we go ahead from here? Similarly, for cos 3 theta as well, there is a version which is 4 cos 60 minus theta, cos 60 plus theta, same version. And do remember, if I club these two, which two, students? If I club this one with this one, then sine 3x upon cos 3x, that will give me tan 3x. This 4 will get cancelled by this 4. So sine upon cos, sine upon cos, sine upon cos. So can you help me with the formula for tan 3 theta? Of course, we know a formula for tan 3 theta, but in this format, it will be tan 60 minus theta into tan theta into tan 60 plus theta. I hope you will remember that, and beware that after this session this entire PDF will be shared on our WhatsApp channel. So you can scan the QR code given in the beginning or even the description of this video, from where you can have this entire PDF of 200 pages in your message. Yes, on WhatsApp. We'll be sharing it on our WhatsApp channel. Now from here, yes, we know that for tan theta, it is always 3 tan theta minus tan cube theta upon 1 plus 3 tan square theta. Will very much be needing it in, inverse trigonometric functions. So there you got to remember it, that tan 3 theta is always 3 tan theta minus tan cube theta upon 1 plus 3 tan square theta. It is derived from tan a plus b plus c, where it is tan a plus tan b plus tan c minus tan a into tan b into tan c upon 1 minus tan a tan b plus tan b tan c plus tan c tan a. I hope you remember that. So from there it has gotten derived. Now something very crucial here. If you see cos is getting multiplied and the angles are in GP, cos A into cos 2A into cos 2 square into cos 2 cube A, and so on. So if angles are in GP where the common ratio is 2, did you listen to what I've just said? I repeat, if you see cos is getting multiplied and angles are in GP, so A is there, then 2A, then 2 square and 2 cube A. So all you do is simply multiply and divide it by sin A. I repeat, that's good, Rudra, good to have you. All I'm saying is that if I multiply and divide it by sin A on both the sides, that is in the numerator and denominator, so sin A in the numerator and sin A in the denominator. Of course, you got to have a 2 as well. So with this 2 sin A cos A, it becomes cos 2A, then that cos 2A into sin 2A, then again 2, then again this becomes sin 4A, and so on. So this chain becomes, and finally it concludes with this sin to the power n A upon to the power n sin A. I hope you're understanding it. But here, this should have ended with 2 to the power n minus 1A. So this value is multiplied with another 2, and that's how you get the final angle. Can you directly write this result now? I hope you must be able to remember this. Everybody with me on this, all the participants. So instead of doing this time and again, you can directly apply this formula. But the catch here is the angles should be in GP, where the common ratio should be 2. That's great. Good to have you all, students. Moving ahead from here, yes, logarithmic differentiation. Yes. A lot many times you are given logarithmic differentiation where you are supposed to take log and then differentiate. There is a simple catch. How do you differentiate it? The idea is really simple. This is also one of the methods, but right now at this stage, I won't, unnecessarily panic you. You can directly apply the logarithmic differentiation in the manner you have been applying. Take the log on both sides and differentiate it. Don't remember this. If you want, you can revise it later by yourself. You can take the screenshot. Of course, we'll be sharing the PDF as well. So don't worry about that. Now there comes something. Sin mein aaya to, in that case, we don't have any other choice. For addition, we have the formula, Rudra, but for this product in sin, we don't have any choice. Good to have you, Ajay Singh, and everyone. I repeat my part very clearly. Pay attention to this part, everyone. Differentiation based determinants were also there asked. Please remember that. There have been questions where you first of all simplified those determinants. We have seen questions when we were solving previous year's questions, and then one of the rows or one of the column got differentiated because the other two rows were constant and they became 0 when differentiated. So I hope you remember, if there is a determinant where you are having this, in that case what you do is differentiate first row, keep other two rows intact, plus differentiate second row, first and third row intact, plus differentiate third row, second and first intact. You could have done it column wise as well. That is also absolutely doable. Good to have you all. One thing you should clearly remember here is that if sine and cos angles are given in terms of AP, then there is a formula which we'll be revising. Don't worry about that. Now here, when I go ahead with this, yes, there is something very important and crucial based on functions. So let's say here, they ask you number of mappings, which means what? In the domain set, there are m elements. In the codomain set, there are n elements. I'll simply ask you to be logical because they keep playing with a lot with the data. So you cannot just remember the formula and apply them. They won't ask you questions based on formulae because they want you to use your brain. And if you could remember the logical approach, you will be in a better position to figure it out. What do I mean by that? If there are m observations, there are n observations and they are to be mapped. So here, if I ask you the number of functions from A to B, so if I approach this x1 and ask it how many choices do you have, so it will say I can be mapped with either y1 or y2 or y3 until yn. So x1 has how many choices? N choices. Similarly, x2 also has n choices, x3 has n choices, so on, and xm also has n choices. So this n is getting multiplied how many times? This n is getting multiplied m times, which means it will be n to the power m. So the number of functions from set A to set B, where set A has m observations, set B has n observations, the number of functions will be n to the power m. Basic, easy, simple. I think nothing much is needed to be said here in this case. From here, remember this, always remember this. Okay, great famous user. No, that's the function. Now for onto into we'll discuss a formula, don't worry about that, but Rudra, that's the basic idea you develop for the number of functions. Now if I get back to this, remember this, if you are given f of x into f of 1 by x, please remember that whenever you are given f of x into f of 1 by famous user, I'll do that. We'll take a separate doubt session. Here we are supposed to revise all the formulae. Once we are done with all these formulae, we'll take your doubts in another separate session and I'll be taking care of all your doubts. Don't worry about that. Now let's focus here. F of x into f of 1 by x. If it is given as f of x plus f of 1 by x, in JEE Mains 2026 only, they had asked a question in the January attempt. Now, this function, if this functional definition is given, can be written as either 1 plus x to the power n or 1 minus x to the power n. So whenever you are given something like this, it is always 1 plus minus x to the power n. Now, you have ambiguity here. It could be either plus or minus, and what could be the value of n? So to figure out these two values, whether it will be plus or minus, or what could be the value of n, in that case, please remember, you'll be given certain data, and with that you can figure out what will be there, either plus or minus, and what will be the value of n, so that you could figure out the exact function. Okay. Yes, famous user will do that after the session, in the doubt session separately. Onto निकाल के में ही करते हैं ना. Function can be onto or into both. Function can be many one or one. So that depends. I have simply given you the idea that number of functions, how many they can be. So that I have tried giving you. Rudra, it could be onto, it could be into, it could be many one, it could be one. So all sorts of are covered in that formula, n to the power m. Now here, when I go ahead with this, I hope you'll remember this result very clearly. Some properties based on modulus you all are aware of, that yes, something very crucial. Students commit a lot of mistakes here. Under root over x square is always mod x, and there something very simple and straightforward is that these two identities, please remember them. I wouldn't say much about rest of the things, you all are aware of them. But yes, sometimes in quadratic equations, they ask you questions where the expression x square, let's say something like this is what you're dealing with, x square plus 2 times mod x plus 3, let's say, for a while. So of course you can write it as mod of x square plus 2 times mod of x plus 3, so that this entire equation becomes an equation in mod x and you can solve this. I hope you are getting it very clearly. From here, when I go ahead, yes, these are some really crucial ones which you can directly keep at your fingertips now, because you need it a lot. For example, here, whenever you're given that mod x is less than a, now I hope you have mugged it up, you have memorized it very clearly, that x will be between minus a to a. If mod x is greater than equal to a, of course a is positive in both the cases. If mod x is greater than equal to a, then we say that either x is less than minus a or x is greater than equal to a. I hope you know that result very clearly. With that, this third result also you should keep in your mind. When mod x lies between a and b, when mod x lies between a and b, where a and b both are positive, in that case x will be either from minus b to minus a or from A to B. Please remember these results. They are the direct formulae which you got to keep with yourself. I hope there is no confusion on that. Now there is something very crucial. They ask you questions based on quadratic upon quadratic. So a polynomial is given where it is either linear upon quadratic or quadratic upon quadratic, and you are asked to deal with its range. How do you deal with this? Rudra is saying, sir, one more, अगर function r से r हो तो x की odd power 1 होती है, and even मुझे क्यों नहीं होती, even में क्यों नहीं होती? क्योंकि रुद्र, in even the function, let's say if it is biquadratic, for example ax to the power 4 plus bx cube plus cx square plus d, then when you find its range, it depends on a. Now if a is positive, in that case it will be drawing a shape like this. So it will be from infinity, coming from infinity, going back to the infinity, but it will attain a certain minima. This will be its global minima. in that case we see its range will be from something significant to infinity. So it is not minus infinity to infinity. Or even if a is negative, the coefficient of highest degree term is negative, in that case the biquadratic's graph will be like this. So if the degree of the polynomial is even, in that case it will be either from minus infinity to a significant value or a significant value to infinity. That will be the case. But for odd functions, they always go like this. So if a is positive, for a cubic polynomial, let's say ax cube plus let's say bx plus c, this is an odd degree polynomial. So it will go from minus infinity to infinity if a is positive, and if a is negative, it will go from infinity to minus infinity like this. Yes, Rudra. You can directly remember it as a result. Now, getting back to the discussion we all were having, I repeat my part very clearly that here, if you have quadratic upon quadratic or linear upon quadratic, the funda is really simple. You multiply this denominator here, you treat f of x as y, so you multiply it with y, and there it becomes a quadratic in x. It becomes a quadratic in x. Here it may be looking very confusing, but you can always remember this. Now it becomes a quadratic in x, and here this expression exists for all the real values of x, which means this expression will have real values of x, real roots of x, real solutions. So if this quadratic has real solutions, its discriminant will be greater than equal to 0. So when you put its discriminant greater than equal to 0, you get inequality in y, and when you solve that inequality, you get the range of this expression, which means you get the values of y. I hope you got that. Sir, तो n से n तो odd power नहीं होगी ना, 1 1 and on 2. I am not able to get your statement, or be more specific, be more clear. I'll definitely give you insights on that. Now I hope you got this, that whenever a quadratic upon quadratic or linear upon quadratic is given and you're asked to figure out the range of this function, all you got to do is cross multiply. You will see a quadratic in x, solve that, don't solve that quadratic in x, just assume that that quadratic will be acceptable for all the real values of x, which means it should have real roots. In order to have real roots, its discriminant will be greater than equal to 0. So when you put that condition, you will find the range of y. By applying wavy curve method, you can finally find the answer. But anyways, for simple expressions or quadratic, you don't even have to think about the wavy curve method as well. Now from here, when I go ahead, there are certain properties of odd and even functions you should be aware of. What are they? Let's begin with them. Function n se n ho to. In that case, Rudra, which function are you asking? What are you asking? I'm not able to get your question. Write a proper question, What are you asking? What details are given? And I think for that doubt session, we'll conduct a different session where we'll be taking care of all your doubts. Don't worry about that. But right now, let's cover all the formulae. But yes, if there is a doubt related to these formulae, we'll definitely address them. Do write in the comments. Now here, if I get back to this, product of two odd functions or two even functions is an even function. It's like negative, negative or positive, positive. But I hope you remember, negative into positive is negative. That means what? Product of odd and even will be an odd function. I hope you remember that. And something very crucial, any function can always be expressed as a sum of an even and an odd function. What does it mean? Here, let's say if you're given a function, f of x. Now this f of x I can write as f of x plus f of minus x whole divided by 2 plus f of x minus f of minus x whole divided by 2. When you simplify this, f of minus x are cancelled, and 2f of x by 2 gives you finally f of x. But if you pay attention to this part of this function is the even part, and this part of this function is the odd part, which means every function in this world can be expressed as a sum of an even function and an odd function. JEE has been asking questions based on this, and then they may ask you in the April attempt as well. So remember, if you are asked to write a function as a sum of two functions where one of them is even and the other one is odd, you got to apply this technique. Will you remember that, all the participants? Now if I get back to the discussion we were having here, again, the derivative of an odd is always even, the derivative of an even is always odd. Remember that. And yes, a function which is even or odd, when squared becomes an even, because even into even or odd into odd, that is even. We already have discussed that. And the only function which is both even or odd is 0. So let's say in a question, what JEE does is they don't take you or give you the values explicitly or directly. What they do is they play with your emotions, they play with your brain. So instead of stating a number is 0 directly, they may say that there is a function which is even and as well as odd. So in that case, you should remember that function could be nothing but f of x is equal to 0. Will you remember that, all the participants? Now from here, this is the periodicity of the functions. For example, if you are given sin x, cos x, sec x and cosec x, and they are raised to a certain power, this is what you need more at two places. One, in definite integration when you apply kings or queens or periodicity of functions, and second, with the definite integration, area under the curve. There you need these identities a lot, these results a lot. What do I mean by that? If sine, cos, secant, cosec, sine, cos, secant, cosec, so sine and cos and their reciprocals, if they are raised to a certain power, and if the power is even, then their period will become pi, and if the power is odd, their period becomes 2 pi. I hope you'll remember that. Similarly, if you have 10x and cot x, and if they are raised to a certain power, whether odd or even, it doesn't matter, they'll have their period to be pi. You got to remember this slide. Please keep it with yourself. Don't forget that. And whenever you put a mod on any of these, sin x, cos x, 10x, cosec x, sec x and cot x, the period becomes pi. Yes, we do remember fraction part of x. I hope you remember x minus gi of x is nothing but fraction part of x. Fraction part of x is also a periodic function, and questions based on this are asked in definite integration, where you play a lot with limits, you break the limits and you finally solve the question. So based on GIF and fraction part, they are asked, and whenever you are dealing with fraction part functions, remember its period is also 1. And remember, if fraction part of x is given between 0 to 1, in that case, it can be written as x only, because between 0 to 1, fraction part of x is x only. So we try to do that. We try to bring our limit in such a manner that it is between 0 to 1, so that we can substitute fraction part of x by x. Will you remember that result? Now remember, for algebraic functions or irrational functions, the period doesn't exist. They are not periodic at all. But if you talk about these functions, which is a constant, that again is a periodic function with no defined or specific period. I hope you got that. Now there is something which they play with your expressions when they give you a periodic function, and they play with the data. For example, here, if f of x is a periodic function with, let's say, period t, then c times f of x will also be a periodic function with same period. F of x plus c will also be the same function with that same period t. Even f of x plus minus c will also be a same periodic function with period t. But what is the challenge? The challenge is simple. If you are multiplying a value to x, for example, 7 sine 2x plus pi by 9. So this 7 doesn't matter. This pi by 9 doesn't matter. So you just look at this sine 2x. Tell me the period of sine x. Sir, for sine x, it is always 2 pi. But it is what? It is 2x. So multiply that, divide that period by the coefficient of x. So coefficient of x is 2. Take its mod, magnitude, absolute numerical value, which is 2. So 2 pi by 2 will be pi, and that will be the period. Doubt, how do I remember which trigonometric functions are even or odd? Through graphs, Rudra. Array, how can you ask that question at this stage? We know sine of minus x is minus sine x. That is clearly odd. We know cos of minus x is cos of x. So that is clearly even. And if I take their ratio, I'll have tan of minus x, which is minus 10x. So 10 is odd. So that is how you remember. And even whenever you see a function which is symmetrical with respect to origin, that is an odd function. And whenever you see a function which is symmetrical with respect to the y-axis, it is an even function. No, you are not late, Saravan. You can watch this remaining part, or the part which you have missed, later. But right now also, we have just started. So everybody got this part. Can I move ahead from here, all the participants? Now let's focus on the next part. This is the most crucial part. That's where they play with your brain. That's where the trick comes into picture. There, you need to be more cautious and careful. Which part, students? Let's say two functions are given. One of the functions, tan and sec, please remember, sine and tan are odd, cos is even, so their reciprocals also are same. I hope you'll remember that. Now, going ahead with that, remember this. Let's say one of the functions has a period which is a rational number, and the other function has a period which is irrational number. So remember, you say that, sir, if two functions are added or subtracted, then their cumulative period is the LCM of their periods, individual periods. But remember, the catch here is that if one of the functions has a rational period and the other function has irrational period, for example 2 pi, so pi is an irrational number, so there you cannot take the LCM of a rational and irrational number. Let's say one of the functions has a period 3 for a while. Let's say we found it. And the other function has a period 2 pi. So let's say t1 is 3, t2 is 2 pi. Now, if you add these two functions and ask me what will be their period, so first of all, LCM of 3 and 2 pi cannot be taken. And that's where it will be again non-periodic. I hope you understood that. But let's say if you are given two irrational numbers or two rational numbers, then you can find their LCM. I repeat, let's say if there is a function, which has the period, let's say 2 pi by 3, and there is another function which has the period, let's say 5 pi by 4. So if these two functions are added or subtracted, in that case, that function's period will be LCM of this. And remember, LCM of fractions is taken by LCM of the numerator, which is LCM of 2 pi and 5 pi, and HCF of the denominator, which is 3 and 4. So 2 pi and 5 pi, the LCM will be 10 pi in the numerator, and the HCF of 3 and 4 is going to be 1. So 10 pi by 1, that will be the period of the function of summation or subtraction difference of those two functions which are having their individual periods as 2 pi by 3 and 5 pi by 4. Everybody got that? All the participants, are we clear on this? Now moving ahead from here, what do we see next? Yes. Now, this is the part where I think you'll get more clarity, those who are asking about 1, 1, onto many, 1 and all. So here, let's work on that. Let's say here, I am given m observations here and n observations here in the codomain. So domain has m observations, codomain has n observations. Now what do we do here? We are asked number of 1-1 mappings. Now what do I mean by 1-1 mapping? Again, instead of learning this formula, I'll still say apply logic, because JEE will place somewhere with the data and they won't let you apply this formula directly. Rather, they'll put some constraints there, and with those conditions you got to figure out the answer or the result. So there, if some conditions are put, these formulae don't work. The logical approach, the intelligent brain comes into picture. What does that say here? Let's say here, if I approach x1 and ask it how many choices do you have, so it will say I can go to either y1 or y2 or y3 or yn. So this first element has n choices. And now since it is a 1-1 function, let's say if x1 is mapped with y2, so x2 does not have the choice to go to y2. So x2 will go to either y1 or y3 or y4 or yn. So x2 has how many choices? n minus 1 choices. Similarly, x3 will have n minus 2 choices, and so on, and so on. So technically here, if I wish to ensure that it is a 1-1 function, in that case, all I need is npm. I hope you're understanding how is this formula coming into picture. So what is npm? Out of these n observations, I'll find n observations here. Sorry, these are m observations. So for these m observations, out of these n observations, I'll choose n observations and I'll map them. So first of all, out of n observations, m observations can be chosen in NCM ways, and then those can be arranged among themselves in n factorial ways. That is nothing but npm only. Everybody got that? I hope you need not remember this formula. You must have understood the logical approach. With that, do one thing, remember one thing as well. What if n is less than m? What if this is less than this? Then we all clearly know there won't be having a 1-1 function. I hope you're realizing it. Because if number of elements in codomain are less, then you cannot have a 1-1 function. Everybody got that? Can I move ahead from here, all the participants? Now, this is something related to the composition of function. Composition of function means what? If f of x is even, g is even. If both are even, then f of g of x or g of f of x will be an even function. Remember that. You can directly remember these results and apply that formula here. If both are odd, then their composition will be odd. If f is even, g is odd, f of g is even. If f is odd, g is even, then also f of g is even. I hope you'll remember that. I hope you would. From there, when I go ahead or move ahead, what do we see? Some functional definition based questions. IDJ asks questions on it. If you could remember these results directly, you will get your answers more quickly. What are these results? Let's focus on them one by one. So if I could begin with the first one, always remember, if you see f of xy is equal to f of x plus f of y, if this is given in the question, then always take f of x as k ln x or 0. Of course, they'll give you a certain question that f of x cannot be 0. Then you can directly take f of x as k ln x. No other choices there. You can always take f of x as k ln x or 0 when f of xy is f of x plus f of y. Please remember that. Yes, Mercy Buster, this is the video through which you can revise all the formulae of your entire mathematics for the JEE April attempt 2026. All the maths formulae, all the chapters I'll be covering here in this video. And if you want to have the PDF, this is going to be a PDF of almost 200 pages. Entire maths formula will be there in this PDF. You can have that by joining our WhatsApp channel. The link to our WhatsApp channel is given in the description. Can I move ahead with that? Here, when I go ahead with the next conclusion, please remember if a functional definition is given like this, that f of xy is equal to f of x into f of y, then don't hesitate in taking f of x as x to the power n. If you are told f of x plus y as f of x into f of y, remember there is a difference. This is f of xy, which is f of x into f of y. This is f of x plus y, which is f of x into f of y. And the first one was f of xy, which was f of x plus f of y. You just remember these properties of these functions and you can directly see these results. I hope you're understanding it. So when this comes into picture, you can take f of x as a to the power kx. Similarly, if somebody says that f of x plus y is equals to f of x is equals to f of y, in that case, that can happen only when f of x is a constant function. Please remember that. And if somebody says that f of x takes all the rational values of x, then f of x will be a constant function. Remember. Very good, Satyam. Very good. The good doubt. Very good doubt. So here, if I ask you something very simple and straightforward, that f of x takes the rational values for all x. Let's say something like that is given. So instead of telling you that f of x is a constant function, how JEE plays with your brain is that it write it in a different, going through the other way, not in a straightforward manner. They may give you the data like this, that f of x is a constant function, but they don't write it like this in the question. What they say is that f of x is a function which takes the rational values for all x. That can happen only when it is a constant function. Please remember that. From here, moving ahead with this, we know transformation of graphs. Now, what do I mean by transformation of graphs? If you are given e to the power x, so we know the graph of e to the power x goes like this. We all know that this is how you draw the graph of e to the power x, which passes through 0, 1 on the y-axis. Okay, Satyam, very good. Now here, if I'm adding 1 to it, so if f of x is added by a c, then the graph is shifted c units above along the y-axis. So it's shifted 1 unit above. If you're subtracting 1 from it, so your graph is shifted 1 unit below. I hope you're understanding it. So this is all related to transformation of graphs. Why are we discussing transformations of graphs? Because you need it in area under the curve. So if you are given this curve, how will you plot it? So there, with this transformation of graphs, you develop that logic. For example, here, I'll talk about that as well, Rudra. Have patience. We'll cover everything. Don't worry about that. I wouldn't skip anything, nothing at all. Now here, if I get back to it, let's say if I'm given y is equals to mod x, and from x, let's say a value is subtracted. Now this value is not subtracted from f of x, this value is subtracted from x. Then the graph is shifted 2 units along the x-axis in the positive direction. This is how the graph of mod x looks like. So I'll just lift it and shift it by 2 units on the right hand side of the x-axis. But what if I am adding to it? So if 2 is added to it, in that case you shift it 2 units on the left hand side. You shift it 2 units on the left hand side. Yes, definitely this will work as a revision session for you right before your JEE exam as well. If you want to do a quick revision of your all the formula of entire mathematics, watch it at 2x. Definitely that also can be done. So keep it saved in your playlist. That will definitely help you a lot. The second conclusion, the third conclusion, transformation of graphs. Let's say you're given a function sin x. We know the graph of sin x, pretty simple. Between -1 to 1, it oscillates like this. This is your function sin x. But what if it is multiplied by 2? So the graph is stretched by 2 units along with the y-axis. Its range becomes -2 to 2. So that same points will be there where it intersects the x-axis. Those roots, those solutions will be same, but it's stretched along the y-axis. So if previously it was from -1 to 1, now it will be from -2 to 2. I hope you're getting it very clearly, all the participants. From here, when I go ahead, the next one is, let's say if you are dividing it by a certain value, if sin x is divided by a certain value, in that case it will be compressed. I hope you're understanding it. Let's say you are given a function graph of sine x, but you are drawing the graph of sine x by 2. In that case, the range will be from minus 1 by 2 to 1 by 2. So there it gets compressed. I hope you are getting it very, very, very clearly. Now moving ahead from here, we all know that if you are given the graph of f of x, if you are given the graph of f of x and you are asked to draw the graph of f of minus x, what is the method you follow here, students? I hope you remember, if this is the graph of f of x, so to draw the graph of f of minus x, all you do is take its mirror image with respect to the y-axis. So if you take the mirror image of the f of x with respect to the y-axis, you will have the graph of f of minus x. I hope you do remember that. Without any confusion, you can always say so. Now from here, the next conclusion. This is something again very important. Let's say you are given the graph of f of x and you are asked to draw the graph of f of minus of f of x. In that case, what you do is, so same formula, session for physics also come or not. Mercy Bistra, I doubt. The session is kept for maths as of now. So here, if I take its mirror image with respect to the x-axis, so if I'm taking the mirror image of f of x with respect to the x-axis, in that case, I'll have the graph of minus of f of x. Everybody listening and understanding that? Can I move ahead from here? The next conclusion. There comes the doubt, students. Rudra Bhatt. Sir, JEE Mains 90 आए फिर भी seat नहीं मिली. No worries with that. Let's aim higher. Let's target better. Let's say this is the graph of f of x. And you are asked to draw the graph of mod of f of x. So f of x becomes non-negative. So whatever part of f of x was there below the x-axis should be reflected above the x-axis. Why? Because the part which is already there above the x-axis will be there, because mod of f of x will be f of x, because f of x is already non-negative. But here, whenever f of x became negative, its image will be taken in the x-axis. So are you understanding this part, all the participants? If f of x is given, how do you draw the graph of mod of f of x? Why are we discussing all this? We are discussing transformation of graphs specifically because you are going to need these formulae in definite integration and area under the curve. There they play a lot with the graphs, and this part comes into picture. Definitely, Mercy Bister, I forward this request to Sumit sir. Don't worry about that. Here, now moving ahead with this. Second conclusion, Rudra, pay attention here. This is the part where this is the curve which is f of x. Now, if somebody asks you to draw the curve or graph of f of mod of x, how do you do that? That's more interesting here. First of all, let's say a function has a graph which goes like this. So first of all, remove the graph of this curve which is there on the negative x-axis and take its mirror image with respect to the y-axis. Did you listen to what I have just said? All I'm saying is that there is a curve f of x. It will have its graph on the positive x-axis and negative of x-axis. But whatever part of this graph is there on the negative x-axis, remove that. And then take the mirror image of this graph which is there on the positive side of x-axis in the y-axis. That will give you the graph of f of mod of x. Yes, I will forward this request to Sumit sir. Don't worry about that. And I'll definitely ask him to bring a session for this. Now, there comes L'Hopital rule. This is a French mathematician. He was L'Hopital, where H was silent. So this is not L hospital. This H is silent there. So this is L'Hopital's rule. Now, what did L'Hopital say? I hope you remember, whenever you are solving a question based on limits, f of x upon g of x is given, where x approaches either 0 or infinity. So if you get x approaches either 0 or infinity or a, but in that case, if f of x approaches 0 and g of x also approaches 0, or both approach infinity, which means it is either a 0 by 0 form or an infinity by infinity form, then I hope you remember you can apply L'Hopital, where you differentiate numerator and denominator separately. I'm not asking you to use the quotient rule. Remember that. Here, you differentiate the numerator divided by derivative of the denominator. Do you remember that result, all the participants? I hope no confusion on that. And yes, if you again get a 0 by 0 or infinity by infinity form, then again you got to use the same approach, right? Now here, the next result is this, the standard expansions. You should be aware of them. Which one are they? E to the power x. Now, this is something which you use not only in this limits, because expansion based questions are there, parameters a, b, c are given, and then you solve it by comparing the constant terms, the same degree terms. So there you find the solutions. Or the second method is you may use it in binomial, you may be using it at somewhere else. So remember these expansions, they are highly useful. They are dominantly useful, very, very useful. So e to the power x should be remembered by you. You all know the expansion of 1 plus x to the power n. I need not tell you. You should remember the expansion of log 1 plus x. It is x minus x square by 2 plus x cube by 3 and so on. You should remember this expansion. I repeat, JEE is in love with this expansion. This particular expansion, they keep on asking every year. This particular one. X to the power n minus a to the power n upon x minus a is x to the power n minus 1 into a to the power 0, x to the power n minus 2 into a to the power 1, x to the power n minus 3 into a square, and so on. And there comes one more crucial, a very important handy result, which is this, that if x to the power n minus a to the power n is given, then you can always say that it is divisible by x minus a, which means remainder will be 0. This direct question was asked by JEE Mains in this January attempt. And remember, if you are given x to the power n plus a to the power n, and when it is divided by x plus a, then also it will be divisible by x plus a for n being odd. So as long as this power is odd, this will still be divisible. Trust me, in the January attempt, there was a direct question based on this, which was there in binomial. I repeat, this identity is it has its own applications. Now moving ahead with some more expansions, if you could remember them. A very important one, I personally remember it like this, that sin x is an odd function. So if sin x is an odd function, we remember it will be having all the odd powers. Cos x is an even function, so cos x will be there with the even powers of x. You remember that? Yes, session 1 mein aaya tha. That's good, Rudra. Again, the expansion of 10x sine inverse x and tan inverse x, if you can remember, please do remember them. Expansion based questions are asked, and instead of applying rationalization or L'Hopital, you can get the answers very quickly if you remember these standard expansions, which I have been highlighting clearly. Now moving ahead from here, what do we see next? This is something we have already discussed. Limit when x approaches a, standard expansion it is, direct result it is, you can apply it directly. X to the power n minus a to the power n upon x minus a is always n a to the power n minus 1. The differentiation kind of a formula, right? And it is derived from L'Hopital only. From here, these are again some standard limits. Sin x upon x when x approaches 0 is 1. So instead of x, let's say here it is sine of something upon that same thing. And if that thing approaches 0, then also it is 1. Are you listening and understanding, all the participants? Similarly, tan x upon x when x approaches 0 is 1, sin inverse x upon x, tan inverse x upon x. But there is a catch. There is again a catch. If this angle here is given in degrees, and if it is given in no degrees, it means it is in radians. That means I got to convert this into degrees. So again, by that adjustment, pi by 180 degree will come picture as an answer. Of course, the other results are same, as I have already mentioned, sine of something upon that same thing when that thing approaches 0, because x is approaching a, so it approaches 1. That logic you should remember. Please don't forget that. Something again very crucial, please remember these results directly. There are a lot of formulae, we'll be covering everything, don't worry about that. Log of 1 plus x upon x, if x approaches 0 is 1, you can generalize this result with L'Hopital as well. X approaches 0, e to the power x minus 1 upon x is also 1. X approaches 0, a to the power x minus 1 upon x is ln a. Please remember that. If it is e to the power x, then it is 1. But if it is a to the power x, the limit will be ln a. I hope you will. Don't forget that here. Now, if f of x and g of x both are approaching 0, if both are approaching 0 when x is approaching a, which means if I'm given this expression 1 plus f of x raised to the power 1 by gx, which means it is 1 to the power infinity form. It is 1 to the power infinity form. Then there is a direct shortcut. JEE again is in love with this particular formula. They ask a question every year in almost every shift. How do we use it? The answer you can directly write as, e to the power x approaches a, 1 plus f of x minus 1, which is f of x into 1 by gx. This is the expansion of some other result. This is the expansion of this result, f of x to the power g of x, where this is approaching 1, this is approaching infinity. So the answer is given by e to the power f of x minus 1 into g of x. That will be your final answer. Only and only if this is 1 to the power infinity form. then only it is applicable. So what if it is a 0 to the power 0 form? In that case, take logarithm both sides. You will see same kind of scenario getting delivered, and then again you can figure out the final answer. Are you all listening and understanding, all the participants? Can I move ahead from here? Now there is a catch. This has always been a matter of discussion. Their students commit a lot of error. We had discussed the graph of sin x, tan x and x together. I did discuss when I discussed trigonometric functions. In the one shot of trigonometric functions, we have discussed the cumulative, the combined graph of sin x, tan x and x. And there I gave you the comparison that you should see it like this, that is sin x upon x is given. Then if it is approached from left hand side, it approaches 0.999, 0.9998 and so on. But if it is approached from the right hand side, then it is somewhere greater than 1. It is somewhere greater than 1. So if its left hand limit is taken and its GIF is done, so sin x upon x, its GIF is taken and then x approaches 0 is applied, then please remember it is 0, because when it is approached from left hand side, it will be 0. But if it is approached from the right hand side, it will be 1. I hope you are listening and understanding. Any confusion on that? Any confusion on that? All the participants, I hope you'll remember that. What do I mean by that? Tan x upon x from the right hand side approaches 1, which means tan x upon x GIF when x approaches 0 will be 1. But sin x upon x when x approaches 0 is done and GIF is put, then don't say it will be 1, it will be 0. Please remember these small nuances, they matter a lot. You don't become more intelligent when you talk a lot of stuff, when you exaggerate a lot. You become more intelligent, you become more insightful, you sound more intelligent or logical when you know these nuances, when you know these basics. And this exam is all about knowing the basics. Yes. Niladri, I doubt whether Gaurav sir will be doing that not, but Sumit sir and Gaurav sir are aligned. They'll be making you revise entire chemistry and physics in the upcoming session, in the upcoming days before second. Okay, great. Now only I see the video about top 10 repeated topics. Is it enough? I'm not good in maths. Right now, Saravan, that will be the savior. Go ahead with that. I wouldn't say much about that. Which formula, Rudra, which formula? How can you say direct 1 by 2? Now here, this is your Newton-Leibniz formula given by Newton and Leibniz separately, but both of them contributed to calculus coincidentally together. I mean, one was a German scientist, one was an English scientist, but they developed mathematician. They developed calculus together and they coexisted. So in Germany, Leibniz was developing calculus in his own world. Newton was developing calculus in whole world, in England. And coincidentally, they gave us same results. They gave the same results. When their book were read, then when the papers got published, the same results were there. So yes, this is a formula which was developed by both. So it is credited to both Newton and Leibniz both. What is it? Let's say if you are asked the definite integration of an expression and then you are asked to integrate it. So one of the methods is you do it, you integrate it first and then you differentiate it. But Newton-Leibniz suggested that you don't have to integrate it. What did they say? They said that if Ix needs to be differentiated with respect to x, where what is Ix? Ft dt from psi t, phi t to psi t. So what does Newton-Leibniz say? I hope you are aware of it. Psi t is passed to ft, so it will be f of psi t, then derivative of this psi t minus phi x is passed to f of t, which is f of phi x into derivative of phi x. I hope you do remember that. And this is something which they use in questions of differential equations, because they may give you something like this, and then by applying this you can get it converted into a differential equation and then you will be solving it. Or they may ask you in limits based question where 0 by 0 or infinity by infinity is used, then you apply L'Hopital and then apply L'Hopital on something like this. Again Newton-Leibniz comes into picture. So it is again a very important formula which you could be using anywhere in the calculus based questions. Will you remember that? From here, when I go or move ahead, what do I see? Limit as a sum. That is again something very important. Not only in questions of limits, but also in the questions of definite integration, you use this. So questions which are there in terms of sequence and series could either be used with sequence, squeeze theorem or sandwich theorem, or sometimes those questions can be done with the help of limit as a sum. That is definite integration as well. How? Please look at this. In yesterday's revision session, we did discuss one question based on this limit as a sum as well, where a very decent, simple, straightforward example was taken, and just to keep you make you understand that how is this formula applied. So remember, the standard formula is really simple. Summation f of r by n is given, where r is from phi x to psi x, 1 by n, and n is approaching infinity. So what you do is, first of all, you replace r by n by x. So integration of f of x is done. This summation is replaced by integration sign. This 1 by n limit is approached by dx. Now you put the lower limit and upper limit. Now how do we calculate the lower limit and upper limit? R is phi x. So r by n, which means phi x by n, when n approaches infinity, will be a, and psi x by n when n approaches infinity will be your upper limit. I hope you got this. Everybody listening and understanding. Now here, when I go ahead or move ahead, what do I see? Yes, these are some standard results related to continuity. You got to remember them. What are they? Sum, difference, product, and quotient of two continuous functions is always a continuous function. Please remember that. Given that in division, g of x should not be 0, add those values of x. Then, if f of x is a continuous function and g of x is a discontinuous function, then the product function f of x dot g of x is not necessarily be discontinuous at that value. Remember, product of a continuous function and a discontinuous function is not necessarily a discontinuous function. Please, please, please remember that. Which part, Zoro? Which part are you asking me to repeat? This part. So limit as a sum means if f of r by n is given, you replace it by f of x. This summation gets converted into integration. 1 by n and limit are replaced by d of x. When you talk about upper limit and lower limit, this psi x, this phi x is replaced by r. So phi x by n when n approaches infinity will give you the lower limit. Phi x by n, r is replaced by phi x. So phi x by n, psi x by n when n approaches infinity will give you the upper limit. Did you understand this now, all the participants? Are you all there, listening, watching, and understanding this clearly? Now from here, when I go ahead, what do I see next? Yes, this is, I think we have already discussed. I need not make you revise this. This is something more important. This is the most important or one of the most important results of your discussion we are having today. Please, please, please don't forget this result. Now, what does this result say? This result gives you a very important, insightful discussion where f of x is a differentiable function. Let's say at x is equal to a. You can apply it directly and mark the correct option without even thinking or applying much knowledge. What does this theorem say? Pay attention to that. And f of a is a, and g of x is continuous at x is equal to a. Three things I know. Then this product of f of x into g of x, what I know clearly is that this f of x is differentiable at x is equal to a. That is true. Second thing, this function f of x at a is 0. That second thing I know. Third thing which I know is that this g of x is continuous at x is equal to a. If these three conditions are fulfilled, then please remember their product will be differentiable at x is equal to a. You need not check its differentiability by taking LHD and RHD. You can direct write this result. Which two things? Product of two functions, where one function is absolutely differentiable, second function is differentiable or not, I don't care. What I understand or know is that this, which is differentiable, should be 0 at that point, and second one should be continuous at that point. If those conditions are matched, then without even checking it for the differentiability, I can directly conclude that f of x into g of x will be differentiable. Just give me a quick update in the comment box. Everybody understood that result? Will you all remember that result, all the participants? Can I move ahead from here? Everybody with me on this? All the participants, everyone with me. Now here, approximation, how does it come into picture? There are questions asked on approximation. Let's say they're asking you the approximate value of under root 101. So how do we find it using differentiation? I hope you remember. I can take a function f of x as root x. There I get f dash xx 1 by 2 root x. Great, great, good, good, good. And then if I take x as 100, del x will be 1. So for approximation, I hope you remember the formula is f of x plus del x minus f of x is f dash x upon del x. Because we know f dash x is what? F of x plus del x minus x upon del x, y2 minus y1 upon x2 minus x1. That's your derivative. I hope you remember that. So with that, f of x plus del x, where del x is 1, so it will be under root 101. F of x, that is under root 100. This will be f dash x, that is 1 by 2 times under root x, that is under root 100 dot 1, because del x is 1, the difference is 1. So with that, this is what we need. This is what we know. This is what we know. And by simplifying this, I get the final answer. So approximation can be done with the differentiation. Will you remember that? That's good. Good to have you all. All the participants keep responding like this. From here, I hope we know this result very clearly, but there comes a very important part where you talk about length of normal, length of tangent, length of subnormal, length of subtangent, although it is omitted, but it is used in coordinate geometry. So you may be asked questions based on that. Now, how do we apply that result? Let's work on that. So let's say there is a curvature and there is a point on that curvature. So if I differentiate that curve and its derivative, if I substitute those point x1 comma y1, what do I get? I get the slope of the tangent to that curve at that point. I hope you remember that. And if I take its negative reciprocal, I'll get the slope of the normal. I hope you remember that. No confusion on that. This is a result which is used in differential equations as well. They may ask you that slope of the tangent to this curve at a random point x comma y is given by, let's say, y upon x. So you put dy by dx is y upon x, then you make it differential equation, then you solve it, variable separable form, let's say you use it, and then you find the general solution or maybe particular solution based on the data given to you, and that's how you solve it. Sir, ye aayega JEE Mains mein? Yes, Rudra, but I definitely in a short manner cannot say, because in your shift what can be there that I cannot predict, but yes, things are definitely going to be asked. Okay. Now from here, one thing which is there, which you should remember from coordinate geometry's perspective, whenever you deal with a second degree curve, whenever you're dealing with a second degree curve, I hope you remember ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 could represent either a pair of straight lines, or a conic. So we remember it like this: A, B, C on the diagonal, H, G, F here and here. Symmetric matrix it is. So if its determinant is found to be 0, that means it represents a pair of straight lines. But if the determinant is not 0, then it could represent a conic. If the determinant is not 0, then it represents a conic. Conic means it could be either a circle or a parabola or an ellipse or a hyperbola. Of course, in order to call it a circle, the coefficient of x square and y square should be same, and the coefficient of xy should be 0. And if it is a parabola, ellipse or hyperbola, then we remember one more condition, h square minus ab. But one thing is clear: if it is a conic, circle, parabola, ellipse or hyperbola, and if I'm given a point lying on this conic, let's say x1 comma y1, it lies on this conic, then even without using differentiation, you can write the equation of the tangent within 10 seconds. How? Just listen to my part. This is applicable for second degree conic, not for third degree conic. Second thing, that point must lie on the curve. If the point is outside from where you are drawing the pair of tangents, then no, it's not applicable. The short technique is applicable only when the point lies on the curve. So what does the short technique say? X square in this equation should be replaced by xx1, y square in this equation should be replaced by yy1, x in this equation should be replaced by x plus x1 by 2, y should be replaced by y plus y1 by 2, and if you see a term in xy, you should replace it by xy1 plus yx1 by 2. If you do that in this equation, you get the equation of the tangent to this curve at that point x1 comma y1. Did you understand all what I've said? Everybody with me on this, all the participants. Now let us quickly take a 10 minutes break and then we'll resume. So we'll resume at 11:15. I hope that's okay. Let's take a break. Let's just have some water and then we'll resume in 10 minutes. Okay? So we'll resume in 10 minutes. I hope that's fine and okay with everyone. Okay, so I think you all are having a great discussion. I can see some motivation also coming into picture. That's good. Keep inspiring, keep motivating, keep pushing each other. That's good. So we believe in collective evolution. So yes, you keep evolving together. That's good. Good, Rudra, that you're inspiring and motivating others. So whenever you're given two curves and then you're asked to find the angle between those two curves, what does it mean? Let's say these are the two curves and they intersect like this. So angle between those two curves is simply nothing but what? At the point where they intersect, you draw the tangents to those curves. And the angle between those tangents at those points to the curves give you the angle between those two curves. First of all, did you understand the meaning of it? And then how do we find it? First of all, we differentiate the first curve. We push that point of intersection, that coordinate, so that we find the slope of that tangent. We differentiate the second curve. We put that same point of intersection there in that second curve's derivative. So we find m1 and m2, the slope of those tangents. So m1 minus m2 upon 1 plus m1 m2 gives you the tan theta between those angles, between those curves. I hope you remember that. So I hope we are clear on that front. Now this is the concept of global maxima, global minima, local minima, and all. Just give me a second, students. Let me just fix this AC here. Yes. Now, great, great. Good to have you all. I hope you all are there listening, watching, and understanding it very clearly. Now, moving ahead with this, whenever a curve is decreasing, its derivative will be negative. Whenever a curve is increasing, its derivative will be positive. Whenever a curve attains its either local maxima, global maxima, or global maxima or global minima, in that case it will be having a critical point there, which means its derivative will be 0 here. If a point here is there which is taking a sharp turn here, so here we can clearly see this function is non-differentiable. I hope you know that. So this is how you understand the concept of increasing, decreasing, strictly increasing, strictly decreasing, global minima, global maxima, local minima, and local maxima. So if a curve's increasing nature or decreasing nature is asked, we differentiate it. And Vishwagar, I think I'm already very slow. So here you find its differentiation, you find its derivative, and with its derivative, what you do is you apply the inequality. If we are asked at what places, at what values of x it is increasing, we put greater than equal to 0, decreasing less than equal to 0, strictly increasing greater than 0, strictly decreasing less than 0, points of critical points, then we put it equal to 0. So that's how we find these values, right? I hope that part we already know. I need not put more detail on that. Nth derivative test. What is happening there? Yes, if you are interested in finding the local maxima, local minima, global minima, so usually with the second derivative test, we find it. What we do in that case, I hope you remember. First of all, you find derivative of it, f dash x. You put it equal to 0. By solving it, you find its roots. Let's say you find the roots as alpha and beta. Then you find its second derivative, that is f double dash x. Then there are three possibilities. F double dash x could be negative, which means fx is having maxima at that point. F double dash x at that point a, x is equal to a, could be positive. That means fx is having minima at that point. Or f double dash x could be 0. That could mean that here point of inflection is there. Point of inflection is there. So curve is changing its concavity, which means if it was concave up, then it may be becoming concave down, and there you saw a point of inflection there. Great, great, great. Now here when I go ahead with this, moving ahead with this, we have this. I think nothing much is needed to be said about this. Let's say you solve f dash x is equal to 0. You found critical points where the solutions were C1, C2, C3, Cn, and there were some boundary conditions. Let's say between closed interval a to b, I need to find its maxima and minima. So between a to b, yes, Rudra, if you want to have the maxima and minima, you got to check it with the second derivative test. If second derivative does not fulfill, then third, then fourth, and so on. But usually with second derivative, you get the final conclusion. Now from here, the next result is that let's say in the closed interval a to b, you're asked to figure out the maxima and minima, or sometimes the range of the function. So what we do is to have its global maxima and global minima, I'll find f of a, f of b, f of c1, f of c2, f of c3, f of cn. All of these are the critical points. So at all of these values, we check the value of the function. So maximum value out of these values is the global maxima. Minimum value out of these value is the global minima. What if the interval is open? If the interval is open, then we don't check the values at f of a and f of b. But remember, the function could be attaining global maxima or global minima there. So we apply limit and find the values. That when x approaches a or b, what could be the value? And there you got to take care of that. I hope you're understanding that clearly through the graph. Now there comes the formula of integration. We all are aware of them as we have already discussed them. I'll simply give you the most crucial ones or the most important ones. A to the power x when integrated is a to the power x ln a, because the derivative of a to the power x was a to the power x ln a. So here it will be a to the power x divided by ln a. I hope you remember that. That's the basic result. And yes, something like this as well, that 1 upon x when integrated gives you ln x, mod of x of course, plus c will be there, which I'm not discussing. Few more important results. Which one? This one. I hope you know that sec square x will be 10x, cosec square x will be minus cot x, mind you. And there, sec x 10x we know when integrated is sec x. There comes the most important one, this one. The integration of cot x is ln sin x. Through substitution you can make it or develop this. If it does not exist, then I'll say it does not exist. If it exists and if it is lesser or greater, then there could be minima or maxima, Rudra. Now here, going ahead with that, integration of 10x is minus of log of mod of cos x, because when you differentiate this, you get 10x. Or by substitution, you can find this result. Few more results are there. I'll say if you could remember these ones. Which ones? This, of course, is used at some places. Integration of sec x, ln sec x plus 10x. Integration of cos x, ln cosec x minus cot x. But what you got to remember here is this one. This 1 upon a square plus x square. The integration is 1 upon a tan inverse x upon a. Very, very dominantly used. And these results, which one? This one. Am I seeing it here in the last slide? Yes, this one. 1 upon under root over a square minus x square, sine inverse x upon a. These results you got to remember. I hope you will. With that, some more come into picture, and integration is something where it's all about memorizing the formulae. You got to learn a lot of formulae. Look at this one. F of x, let's say, has the integration of g of x. Then we all remember f of x plus b doesn't get affected. It still remains g of x plus b. But if x is multiplied by a value, let's say ax plus b is done, then also integration remains g of ax plus b, but that coefficient of x, which is a, divides your solution. So 1 by a of g of ax plus c. I hope you remember that. No confusion on that front. Now from here, some trigonometric identities which will help you in solving questions based on integration. Sir, whenever question from integration is there in mains, I try but I'm not able to solve them. Marshmallow, I totally understand and empathize with your concern. Even I faced a lot of difficulties in integration based questions. The problem there is that you got to strike the right substitution or the right formula there during that limited time, and the pressure of exam is already there. So one thing, by heart all the formulae at this stage. If you can, you should. Otherwise, just practice few questions, look at the previous year's questions, watch the solutions, see the solution, so that you can develop the idea that if this kind of question comes, then this happens. If this kind of question comes, then this happens. Pattern list you should make. Otherwise, Marshmallow, right now at this stage, it will really be difficult. I totally understand that concern. Now from here, whenever you are given sine mx cos nx, so this is a product formula, and with product we face a lot of difficulty in integration. So there we convert this product into addition, and product when is converted into sum, this integration is really simple. So I'm hoping that you will remember all these formulae. They are the conclusions from sin c plus sin d, sin c minus sin d, cos c plus cos d, cos c minus cos d. They are those formulae only if you just look at them. So these formulae you got to memorize and by heart. Now comes the special integrals. Do it at your own risk, because here one question could definitely be asked. It depends on your luck. In January shift, what we have seen is there were very less questions from integrations. If there were 10 shifts, there were hardly 5 to 6 questions from indefinite integration, which means in alternate shifts, questions from integration were seen. This is for you, Marshmallow. So if you are fortunate enough 50% chances are there you may not see a question on indefinite integration at all, or if you are that unlucky one, especially which are using these formulae which are more critical, more complicated, and chances of you committing the errors are more higher there, then you got to learn these formulae. Otherwise, we don't have any other choice. Yes, look for the patterns. And for pattern recognition, Marshmallow, all I'll say is for integration, Samaksh, I'll say go through the previous year's questions. See the solutions now. Don't even solve them. So look at the question, look at the solution, and you will start building that approach, that sense that if this appears, then this is needed to be done. If that category of question comes, this is what is needed to be done. If that is coming there, then you take the common out of that and then you do it. If that comes, then you divide it by cos and then the job is done. If that comes, then you take the denominator's derivative and then through substitution you do it. So that pattern recognition can be developed by looking at a lot of solutions. So go through the previous year's questions of last 4 to 5 years of integration, and then you'll start developing that sense. Okay. Okay. I hope you got it. Can we skip indefinite integration? Totally up to you. Totally up to you. I won't say much at this stage. रोज रिविजन कर और लिख 15 बार हो जाएगा. Yes. It's like medicine. Morning, afternoon, evening. Repeat it. Paste it in front of your study table and rehearse it, revise it. That's the only key to memorize. Now, these are the important formulae. How I personally remember it. We know 1 upon x square plus a square, 1 upon it and inverse x upon a. That is what we know. 1 upon x square minus a square. So through substitution you derive this. I'm not sharing the derivation. It is 1 upon 2a ln x minus a upon x plus a. Mod will be there whenever ln is there. Good to have you, Arpan. And if it is a square minus a square, then also it is 1 upon 2a, but now log a plus x upon a minus x. There is a simple slight difference. Now you got to remember it. And if you make a slight error, the answer will be gone. Here, 1 upon under root a square minus x square. So if it is 1 upon 1 square minus x square inside an under root is sine inverse x, but if it is a square minus x square inside an under root in the denominator, it will be sine inverse x upon a. Remember that. Yes, Samaksh, I totally get this. With that, if it is 1 upon under root a square plus x square, there it will be log x plus under root x square plus x square. If it is 1 upon under root x square minus a square, then it is log x plus under root x square plus a square. So there is some similarity. And if it is in the numerator, then go back to this formula. A square minus x square we have seen here. So use this. 1 upon 2x, this will be same. Plus this will come here, 1 by 2 a square sine inverse x upon a. What similarity I'm trying to show you here? See, a square plus x square. So 1 by 2x a square plus x square inside an under root. Then for a square plus x square, I hope you remember what was the formula. For a square plus x square, this was the formula. In that case, just repeat that part here. Under root x square minus a square. So repeat this, 1 by 2x under root x square minus a square. Minus, for under root x square minus a square, we remember the formula log of x plus this. Then do that. Great. So I'm just sharing my approach, how I personally do it. And if you forget these formulae, you won't be having time to derive that in the examination hall. But if you have that courage to derive it, here are the appropriate substitution which you got to use. Yes, I can empathize. Itna bhi to yaad rehna chahiye. I totally get that. So a square plus x square is there, then x should be substituted by a tan theta and so on. All the correct appropriate substitution I have suggested. Take a screenshot of it. It will definitely save some time in the examination hall. Now comes the quadratic ones. So 1 upon quadratic, 1 upon under root over quadratic, or integration of quadratic. I wouldn't say much. You know to convert it into a perfect square. And the moment you convert it into a perfect square, you will see it getting converted into either x square plus a square form, or x square minus a square form, or a square minus x square form, or under root over a square minus x square, or under root over a square plus x square, or under root over x square minus a square, or anything like that. So these quadratic versions are not different or not special. You just got to convert them into a perfect square. Just give me a quick response. Are you all aware of this? How to convert them into perfect squares? If you can, you will get the results very quickly. Can I move ahead from here? But yes, those results will be attained by you very quickly if you are aware of these special integrals. Otherwise, no, you cannot. Now from here, when I go ahead, yes. Now, if this category of question, okay, Rudra, that's fine. Let's focus here. If you get this category of ones, linear upon quadratic, linear upon under root over quadratic, or linear into under root over quadratic, then again the process remains same. Videsh is saying, sir, sometimes integration question will be word problem using function. Unlike just solving, is there any specific ideas from function chapter? Can you please say it? First of all, I did not get that part, Videsh. Can you be more specific? This is the complete maths revision. I am making you revise all the formulae of your entire maths for JEE April attempt of 2026. And once the session gets over, I'll be uploading this entire PDF on our WhatsApp channel. If you still haven't followed our WhatsApp channel, you can see the link to our WhatsApp channel in the description that will redirect you to our WhatsApp channel. But when you click it, don't get lost on the WhatsApp or Instagram. Come back and watch this session. Don't get lost into this world of internet. Now, sir, your opinion regarding second 20 seconds. Famous user, let's focus here. Why? How does it matter now? Even results are there. It doesn't matter much now. Yes, 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 yes. Great. Perfect. That's exactly Rudra. So in this case, what you got to do is that linear part, this linear part, you write as derivative of the quadratic part plus mu. So lambda times derivative of this plus mu. And with that, by comparing the powers, so coefficient of x here, constant terms here, by comparing them, you find lambda and mu and then substitute. And again, you will find the answer. You will find the answer. Trust me. If you have understood this process, trust me, then the further part of this question, you'll be able to do that. Don't worry about that. Let's say if you are given a polynomial which is greater than a quadratic, which means either cubic or something like that, then you do the division first and then solve it. This category of questions, JEE does not ask much because it requires a lot of calculation. But this again is what they ask, where it is either quadratic upon quadratic or quadratic upon under root over quadratic or quadratic into under root over quadratic. Again, the same process, linear and quadratic, that same thing is done, but with a slight change. That quadratic, which is there in the numerator, or here which is outside the under root sign, that quadratic is written as lambda times the other quadratic, which is there in the denominator or inside the under root sign, plus mu times derivative of that quadratic plus gamma. And again, by comparing the powers, you find the lambda, mu and gamma, and again you can find the differentiation very easily through substitution. Integration using function, I don't understand. Are you asking about differential equations? Because they give you definite integration based question. Then applying Newton-Leibniz rule, you convert it into a differential equation. And then when you solve differential equation, there, finally after putting those values, you find the particular solution. If that is what you're saying, Videsh, we have done a lot of questions like that in Rank Booster series and even in our revision marathons as well. So we have done a lot of questions based on that, right, Videsh? Now, coming back to this part, in this category of questions, what you do is, I hope you're understanding, whenever this sine square or cos square comes into picture, you divide it by cos square. So sine upon cos becomes 10, 1 upon cos becomes sec square, and 10 is substituted by t, sec square t dt, and then your job is done. Again, you get a quadratic, which by solving, you get the answer. If you are seeing something like this, sin x and cos x in linear powers, there just use this. Sin x substitute by 2 10x by 2 upon 1 plus 10 square x by 2, and cos x by 1 minus 10 square x by 2 upon 1 plus 10 square x by 2. Again, you will see that same relation, 10x substitute by t, sec square x dx will be dt, and again you will see a quadratic which you know how to solve. Everybody with me on this? This category of questions IDJE has been asking. We have done a question in the last marathon as well, last day as well. Sir, will there be a similar revision session for physics and chemistry? Our revision marathon is there tomorrow and the day after, today and tomorrow, for physics and chemistry. Marshmallow. So here again the same logic. Lambda times denominator plus mu times differentiation of denominator plus gamma will be expressed in numerator. Again, you compare the coefficients of sine and cos and you get the expression. And again, you will find that integration very easily. Trust me. Then there comes Eilert formula. We know it is first function into second function. First function as it is integration of second minus integration of derivative of first into integration of second. And there when you take first and second, we apply the Eilert formula. I hope you remember that without any confusion. Inverse, logarithmic, algebraic, trigonometric and exponential. I hope you do remember that. From there, this is something which JEE is in love with. they ask you questions based on it. I have shown you questions based on this a lot many times, asked by JEE in the January attempt. The moment you see e to the power x, just split it into two functions where the second function is the derivative of the first function. If you could do that, you can write the final answer even without integration. Your answer will be e to the power x fx. I hope you remember that. So here integration is not needed to be done. Splitting of this expression into two functions is needed to be done, where the second function is the derivative of the first function. Will you remember that, all the participants? This is again a standard substitution where if x minus 1 by x and 1 plus 1 by x square is given, then x minus 1 by x is substituted by t. In that case, 1 plus 1 by x square dx is dt. And again, you find the solution. Everybody with me on this? This again is simple. You just take a screenshot of it, go through it, you will understand it very clearly. Again, the same one, you can go through it by yourself. There comes properties of definite integration. If you say, sir, from differential calculus, limits and AOD are the most important chapters, then from integral calculus, definite integration and differential equation with area under the curve are the most important chapters. Indefinite, you can keep on low priority. So if I begin with definite integration, what we see here is, pay attention to that. I hope you remember 0 to a f of x dx. As per the King's property, a to b f of x dx will be a to b f of a plus b minus x dx. A lot of questions from definite integration can be done with this formula. I hope you do remember that without any confusion. Similarly, its corollary is this: if 0 to a is there, x can be substituted by a minus x. Do you remember that? And with this, minus a to a f of x will be 0 if it is odd, and it will be 2 times f of x minus 0 to a if f of x is an even function. I hope you do remember that. With that, when I move ahead with the periodicity based questions, so I hope you remember this result. You should remember, please, remember this as the direct result. 0 to pi by 2 log of sin x or log of cos x is always minus pi by 2 log 2. Please remember this as the direct result. It can be used in a lot of questions and you can directly get the result very quickly. So if f of x is a periodic function, then 0 to nt, where t is the period, can be taken as n times 0 to t f of x dx. Do you remember that one? I hope all the participants are there. And with that, from a to a plus nt, so that a doesn't matter now, you can write it as 0 to nt, and 0 to nt we know is n times 0 to t. Any tricks? Oh, how can I suggest you any tricks here? You are simply given these formulae and you have been practicing them. It is simply a revision. I won't say much tricks. I'll say logical explanations can be brought, but that we have covered in the one shots. So I think here you got to revise them. I'm just giving you the glimpse so that the neurons, the connections which you have in your brain, get more consolidated, get stronger, so that recall value becomes strong, so that in the examination hall, you quickly are reminded of the correct formula at the right time. I understand there are thousands of the formula in maths only. So when you look at a question, you got to scan through all those thousands of the formula in your brain. And then you got to think of the right formula and you got to apply the right formula at the right moment. And I understand it's really tough. But the better neurons connections you have in your brain, the better recall value you will have and you will be able to recall them more quickly. So I'm just giving you the glimpse. So I won't be having much tricks in all those expressions or for all those formulae, but I'll try to give you the glimpse, or I'll try to make you go through all these formulae. That's the intent or the motive. I hope you all are there. Great. ACPC, what is that ACPC? Here. Now here we know a plus nt to b plus nt. So again, integration from a to b is there because nt and nt wouldn't matter. And in that case, you can write it as a to b f of x dx. I hope you are comfortably understanding everything. Now with that, when I move ahead, yes, this is something very crucial. Yes, limit, range based questions, you are asked that this lies between certain values. So what you got to apply here is something very crucial and important. A to b f of x dx. If function f of x has minima as a small m and has maxima as capital M, then integration of f of x from a to b will be given by small m times b minus a and capital M times b minus a. Will you remember that? This is how you find its maximum and minimum value. Sometimes questions are indeed asked based on that. This is Wally's formula. You can remember it directly. I'll give you an example with that. You might be remembering it. Simple example I'll take. Let's say you are given integration 0 to pi by 2 sine x to the power 6 and let's say cos x to the power 5. Right. Remember, the condition or the catch here is integration from 0 to pi by 2 should be there. Sin x and cos x should be there and their power should be, thank you so much, Rudra. Thank you so much. How will I be aware of that? Can you not Google that simple information by yourself, man? Yeah. If I get back to this, sin x and cos x are given, they are given certain powers there. Now, what I do here is I apply Wally's formula, a very important, a very insightful, a very crucial trick it is. With this again, without even integration, you get the answer within seconds. Let me tell you how. Pay attention to this. Look at these powers 6 and 5. If both are even, then this is done. But I think both are not even. One of them is even, one of them is odd. So one of them is either even or both of them are odd. Then we use this one. Now what does this formula say? M minus 1. So this here, let's say is M, this here is N. I hope you are understanding. So here I'll begin with this 6 minus 1. So 6 minus 1 is what? 5. Then I'll subtract 2 from it. So 5 minus 2 is 3. Then I'll subtract 2 from it. It will be 1. And I stop at either 1 or 2. Then n minus 1. So 5 minus 1 is 4. Then I'll subtract 2 from it. I hope you're understanding. So 4 minus 2 is 2. Then I subtract 2 from it. So 2 minus 2 is 0. That I don't do. And I stop here. Divided by m plus n. So m plus n is 6 plus 5. That is 11. Then again I subtract 2 from it. So 11 minus 2 is 9. 9 minus 2 is 7. 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 is 1. Into pi by 2 is what you do. That's your answer. Are you not realizing within 5 seconds you can write the answer to this question? This is the importance of Wally's formula. He was again a mathematician and he developed this formula. Sir, what if both of them are even? In that case, again, same logic you apply with m and n, but you don't append a pi by 2 there. But if one of them is odd, then you append a pi by 2 there. That's the only difference. Did you all get that? Can I move ahead from here? Yes. It's fire. It's fire. This formula is fire. Look at these mathematicians, how convenient they have made maths for you. These are some higher concept of mathematics which you study in MSc, BSc, or with higher mathematics which you pursue M1, M2, M3 and M4, higher mathematics. But JEE loves asking questions on them. And if you remember these concepts, you can get the answers more quickly. Even without integration, you can write the final answer within seconds. So take that screenshot. I am hoping that. Now comes differential equations. I'll ask you to remember exact differential equations. What are they? With exact differential equations, a lot of questions can be done within seconds. What do I mean by that? Let's say I am given an expression where it is given as y dx minus x dy upon y square is equal to, let's say, x dx plus y dy. So if you remember these results, if you could remember the logic even, then remember y dx minus x dy upon y square. You can always substitute it by dx by y. Derivative of numerator upon denominator. What is that? Denominator is squared. Denominator is derivative of numerator minus numerator as it is derivative of denominator. I hope you remember that. And here, when you talk about d of x square plus y square, so that will be 2x plus, I hope you are understanding, 2x dx plus 2y dy. So that too, if I can bring here, x dx plus y dy can be written as this. Are you all listening and understanding, everyone, all the participants? So with exact differential equations, if you could remember these results, differential equations based questions, even sometimes without linear differential equation, without homogeneous, without variable separable form, without Bernoulli, you can write the answers within 2 steps. Let's say this is the question. How do I solve it? We know this is nothing but d of x by y. And this is nothing but 1 by 2 d of x square plus y square. Are you listening and understanding this? Are you listening and understanding that? So if you remember this differential equation, exact differential equation based formula, you apply integration on both sides. And we know integration of 1 with respect to x upon y is x upon y. 1 by 2 stays like that. Integration of 1 with respect to x square plus y square is x square plus y square, and plus c you put as your final answer. I am asking you to look at these differential equations. Remembering them is not a tough task. Even if I could simplify or tell you one more, for example, here, let me take any of these. For example, any of these if I take, let's say this one, dxy, what would it be? It will be x dy plus y dx. So if you could remember these differential equations, your job is done. So with that, we are done with calculus. Now we are moving towards vectors in 3D. I'm glad that you feel that calculus is easy even in 11th standard. If you're feeling like that, that's brilliant. Now let's revise the formulae of vectors in 3D. Here, let me begin with the first part. We know if there is a point P, and I hope you remember, if its direction cosines are L, M and N, and its distance from origin is R, then LR, MR and NR can also be the coordinates of this point. Because L, M, N is nothing but what? Under root over x square plus y square plus z square, and numerator has x, and R is under root over x square plus y square plus x square, z square. So that and that is cancelled, and you are left with x, y and z here. I hope you do remember that. And when you take the ratios of L, M and N, there you get the direction ratios. So whenever you get the sum of the squares of the direction ratios to be 1, you call them direction cosines. Yesterday somebody was asking this, is minus 1, minus 1, minus 1 and minus 2, minus 2, minus 2 is same in terms of direction ratios? It is. But direction cosine wise they are not. And if it is said to be vectors, then they are different. They have same direction, but in magnitude, in terms of magnitude, they are different. I hope you are getting it. Now from here, the next part. I hope you understand it. If vector R is given by A I cap, B J cap, C K cap, then here A, B, C are said to be the direction ratios of this vector R. I hope you remember that. No confusion on that. Then the next conclusion we have just discussed, if sum of the squares of them is 1, in that case it is clearly going to be the direction cosines. Now these are the formulae which will be there in 2D as well. So if you ask me to convert them in 3D, we know if this is a triangle, any triangle, isosceles, equilateral, any triangle if it is, and if this triangle has vertices as small a, small b, small c, they are the position vectors, then its centroid is vector A plus vector C by 3. These are some more formulae which are very less used. So you can just have a look at them, keep a note of it, but don't try to memorize them. Something very crucial which is asked, angle bisector. What is that? Let's say there is a vector A, there is a vector B, and you are asked acute angle bisector and obtuse angle bisector. So if acute angle is here, obtuse angle is here. So yes, thank you so much Vishwagarv. That's good. By the way, am I pronouncing your name correctly? If it is wrong, then do tell me. With one more person will be touching 50 watching live. I want to touch it. Great. Keep it increased. Keep increasing it. So here, if this is vector A, this is vector B, then first of all, a unit vector in vector A's direction can be taken as A cap. A unit vector in the direction of B can be taken as B cap. And if you do the vector sum, parallelogram, law of addition, then this vector here will be A cap plus B cap. And if its magnitude, any magnitude is taken, then it will be the internal angle bisector, because parallelogram has its diagonal bisecting the adjacent sides. I hope you remember that. And similarly, if I do A cap minus B cap, then I'll get the external angle bisector. Everybody with me on this? Okay, Raghav, that's good. Good to have you all. Brilliant. Now here, this is something through which you find whether they are collinear or not. I'll say for collinearity, we know, I hope you remember the stair method. I hope you don't forget that. In 2D, if I'm given 3 points x1, y1, x2, y2 and x3, y3, these are the 3 points. Similarly, they have given you 3 points x1 I cap, y1 j cap and so on. So with that, what we know is that here I'll have x1 y1, x2 y2, x3 y3 and then again x1 y1. If I add a mod here and multiplied 1 by 2, I'll get the area of the triangle. Stair, how do we expand? This into this minus this into this, plus this into this minus this into this, plus this into this minus this into this. And if this stair, when expanded, gives you the value 0, we know it is going to be collinear. That's exactly what they are suggesting there. Everybody listening and understanding that? From here, we know if there is a vector A, there is a vector B, and angle theta is there between them, the acute angle, then in that case, what we know is that yes, A dot B will be a real number. It will not be a vector. Dot product is a scalar quantity. And yes, A dot B will always be less than equal to mod A mod B, because A dot B is cos theta. A dot mod A mod B cos theta. Cos theta is from -1 to 1, so it will always be less than mod A mod B. If A dot B is positive, which means cos theta must be acute. Theta is acute. If A dot B is negative, which means theta should be obtuse. If the dot product is 0, we know the vectors are perpendicular. In the vectors in 3D, there are a lot of questions, direct questions based on dot and cross product. And yes, a lot of questions are there based on projection formula as well. From 3D, there are questions based on image or feet or the distance of a line from a point along with the different line, or the distance between skew lines or distance between parallel lines. That formula will also revise, but I hope you are aware of that. Here, if I talk about projection of A on B, so I hope you remember it is given by A dot B upon mod B. I hope nothing much is needed to be said. Component wise, dot product, I hope you know, A1 A2 plus B1 B2 plus C1 C2. If A dot B is needed to be taken, it will be A1 B1, A2 B2 and A3 B3. Even angle between them, cos theta, will be A1 B1, A2 B2, A3 B3 upon under root over A1 square, A2 square, A3 square into B1 square, B2 square and B3 square. Do you remember that? All these students. Now from here, these are few formulae which we use a lot, many times. This is simply, we take their modulus, both the sides, and when we square them, the simple algebraic identities come into picture. But with A dot B, it will be A dot B. So it will be mod A mod B cos theta. You got to take care of it. Questions are asked on this. Please remember that. The next thing is here, I think we know that component wise dot product, we know that. Cross product is little tricky. With the dot, you don't have to pay much attention there. But with the cross product, you got to be more cautious, more careful. How? Have a look at that. Cross product cannot be commute, which means if A cross B is there, then B cross A will be equal to its negative. I hope you know that. So those challenges you will face here. And here with cross, we know if I'm doing A cross B, and in maths, we don't talk much about direction. In physics, we do. In maths, we are much interested in magnitude. It is given by mod A, mod B, sine theta. So the way A dot B is cos theta, A cross B is sine theta. And with that, the Lagrange's identity is also produced. Remember this, questions are asked on it. Mod of square of mod of A cross B, square of mod of A dot B, when it is added, it is mod A square, mod B square. A lot many times questions are asked on it. Sometimes they give you the dot product, they give you the magnitudes of them or the product of the magnitudes of them, and they ask you the cross product. So through this Lagrange's identity, you work it out. Please remember that. And I hope there's no confusion on that. Let's say there is a vector A, which is A1 I cap plus A2 j cap plus A3 k cap, and there is another vector B, which is B1 I cap plus B2 j cap plus B3 k cap. Then their cross in component form is given by determinant of I cap, j cap, k cap, then A1, A2, A3, and then B1, B2, B3. I hope you do remember that. That is something they will ask. This will be used in skew lines. This will be used with perpendicularity. This will be used with, let's say, a vector is perpendicular to two other vectors, which means it will be parallel to A cross B. Let's say there is a vector C, which is perpendicular to A as well as perpendicular to, which means C will be parallel to A cross B. So I'll find A cross B and I'll put C as lambda times A cross B. And then through some other condition, I'll find lambda. First of all, triple product is omitted from your syllabus, so STP and VTP are not there, but still if you want to use that, you can, depending on the requirement of the question. This is A cross B in component form, as we have just discussed. This is one of the most important slides of our discussion you should keep with you. Remember this, whenever there is a parallelogram, and if that parallelogram has adjacent sides as vector A and vector B, then its area is given by magnitude modulus of A cross B. If you are given a parallelogram, and its diagonals are given, let's say D1 and D2, In that case, the area is given by half of magnitude of d1 cross d2. Don't confuse it with the area of the triangle. This is d1 and d2, which are the diagonals, not the adjacent sides. If you are given a plain quadrilateral ABCD, where AC and BD are the diagonals, then also this formula is applicable. Everybody with me on this? Second conclusion, if you are having a triangle, let's say this is vector A, this is vector B. In that case, this triangle's area is half magnitude of A cross B. Will you remember that, all the participants? Now from here, yes, we know distance formula is pretty simple. This is an amazing short trick which you got to remember. What is it? Let's say there is a line. This line segment is created by joining 2 points. Let's say one of the points is x1, y1, z1, and the other point is x2, y2, z2. And there is a plane. Although plane is omitted, but if they ask you a question on it, this is how you got to do it. There is a plane. And the equation of the plane is, let's say, ax plus by plus cz plus d is equal to 0. So this plane, let's say, divides this line segment into the ratio lambda is to 1, which means this length is to this length. This ratio is, let's say, lambda is to 1. So this ratio, which is lambda is to 1, is given by m is to n, whatever you wish to call it, is given by power of this point with respect to this plane divided by power of this point with respect to plane, and take its negative. What did I say? Negative of ax1 plus by1 plus cz1 plus d upon ax2 plus by2 plus cz2 plus d will be the ratio in which this plane is dividing this line segment. The same formula I'll be telling you in 2D. What does it mean? It means, let's say in 2D, there is a line and there are 2 points. So in 2D, let's say there is a point x1 comma y1, other point is x2 comma y2, and here there is this line. And this line is having the equation, let's say ax plus by plus c is equal to 0. So let's say if I'm asked that in what ratio is this line dividing this line segment which is created by joining A and B. So how do we do it? I'll find the power of A with respect to that line, which will be ax1 plus by1 plus c. I'll find the power of this point with respect to this line, which will be ax2 plus by2 plus c, and then I'll take this ratio's negative, that will be lambda is to 1. Did you all understand this? All the participants, everybody with me on this? From here, I hope we know that this is something very easy. Now moving ahead with that, yes, if direction cosines are given, let's say one vector has direction cosines as L1, M1, N1, second vector has the direction cosines as L2, M2, N2. Sir, how do we verify that they are the direction cosines? The sum of their squares will be 1. What if they are not the direction cosines? Then also it is fine. Let's say this has direction cosines as A1, B1, C1. This has direction cosines as A2, B2, C2. In that case, the angle between these two vectors, I hope we have just discussed, cos theta is given by, I hope you remember, A1, A2 plus B1, B2 plus C1, C2 divided by under root over A1 square plus B1 square plus C1 square times under root over A2 square plus B2 square plus C2 square. And I hope you remember this one. But if they are L, M, N, L1, M1, M1, L2, M2, N2, in that case, this will become 1, this will become 1. So the formula is L1, L2 plus M1, M2 plus N1, N2. Everybody watching, listening and understanding this comfortably, all the participants. Now there comes the condition for perpendicularity and parallelism. Here, if two vectors are parallel, then L1 upon L2, M1 upon M2 and N1 upon N2 will be same. Even if their direction ratios are given, then A1 upon A2, B1 upon B2 and C1 upon C2 will be same. If they are perpendicular, in that case, L1, L2, M1, M2, N1, N2 will be 0. Or A1, A2 plus B1, B2 plus C1, C2 will be 0. Whatever it is, direction, cosines or ratios, it will be same. Parametric form. This is what we study in 2D, but this is something we study in 3D as well. And on this, they ask you a lot of questions. They give you two lines and then you have to deal with their point of intersection. They give you a line and there you find the perpendicular's feet. They give you a line and they ask you the image of a point. So in all these sorts of questions, what is the modus operandi? First of all on that line, you find a point lying on it in parametric form. So line's Cartesian form is x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. What does it mean? It means that the line is passing. It means that the line is passing through a point x1, y1 and z1, and that the line is parallel to a vector a1, b1 and c1. Or rather, in this case, it is simply a, b, c. I hope you remember that. So equation of the line is given by x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. We put it equal to lambda. So we find x as x1 plus lambda a, y as lambda p plus y1, and z as lambda c plus z1. So this point lies on the line parametrically. Now, depending on the condition, if it is perpendicular or feet or image, you find the value of lambda. I hope you are understanding it. If let's say there is another point given to you, x2, y2 and z2, and there is this point which you have found, let's say this point, which is the feet here. So this point is given by this. So you find the direction ratios of this line segment, which is what? x2 minus that point, y2 minus that point, z2 minus z coordinate of that point. And that gives you the direction ratios. So we got the direction ratio of this line segment, we got the direction ratio of this line segment. And since both of them are perpendicular, again A1, A2, B1, B2, C1, C2, the sum will be 0. That condition can be applied, and through that you find the answer or the value of lambda. I hope you do remember that. With that, when I move ahead, what else do we remember? Yes, condition for perpendicularity, condition for parallelism, we have already discussed. I won't. This is again going to be a very important slide for you all from this chapter. What is it? The distance formula. So here, let's say two lines are given. First line is passing through x1, y1, z1. Second line is passing through x2, y2, z2. First line is parallel to the vector a1, b1, c1. Second line is parallel to the vector a2, b2, c2. I hope you do remember that. So what does the formula say here? First of all, b1, here it should be v1 cross b2. There is a small correction here. Let me make that correction. Just hold on for a while. Here it should be b1 cross b2. So there should have been cross here. So b1 cross b2 dot a2 minus a1. So technically it is the projection of a2 minus a1 on the common perpendicular. Common perpendicular will be v1 cross b2 because this line is parallel to b1. This line is parallel to b2. So shortest distance is always found along the common normal. So this line and this line will be having a common normal, and that common normal will be parallel to b1 cross b2 because it will be perpendicular to b1. It will be perpendicular to b2. So if it is perpendicular to both, that means more probably black mystery another 1 hour. So by 1 o'clock will be done. I hope you are okay with that. So b1 cross b2 will give you the perpendicular to both of these lines. And if I find the projection of a2 minus a1 on that b1 cross b2, I'll be having that as shortest distance. So a2 minus a1's projection on b1 cross b2 will be a2 minus a1 dot b1 cross b2 upon b1 cross b2. I hope you remember that projection formula. That's exactly what we are using here. Everybody with me on this? Sir, what if the lines are parallel? If the lines are parallel, they'll have the same b because they are parallel. So in that case, it is simply a2 minus a1 cross b upon mod of b. I hope you wouldn't forget it anymore. Will you remember that? I hope you remember that after this session, we'll be making you or sharing you this entire PDF of the formulae of the entire maths for your JEE April attempt of 2026 on our WhatsApp group. If you want to follow our WhatsApp channel, this is the QR code by scanning which you can follow our WhatsApp channel, and there this entire PDF of 200 pages will be shared with you. So we are done with calculus, we are done with vector in 3D. Now we are starting with algebra. Then of course we'll have trigo and coordinate geometry. If you are asking me the duration of this, we have already covered the half of this video, but the remaining half theoretically will be done in possibly the next 1 hour. I hope you are okay with that. So within this session, we are making you revise the entire maths, all the formulae for your JEE April attempt of mathematics. Yes, and this PDF will also be shared on our WhatsApp channel. You can see the link in the description. When I talk about iota, we know if iota is under root over -1, then iota has its cyclicity in 4, power of 4. So I hope you remember Iota to the power 4 is 1. So iota to the power 4n plus 1 is iota, 4n plus 2 is minus 1, 4n plus 3 is minus iota, and so on. Sum of 4 consecutive powers of iota is always 0. Because one of them will be iota, one of them will be minus iota, one of them will be 1, and one of them will be minus 1. So 1 minus 1 iota minus iota will always give you the sum as 0. This you should remember, 1 plus iota upon 1 minus iota is always iota, 1 minus iota upon 1 plus iota is minus iota. If you remember it without even rationalizing, you can directly substitute it and get the answer. Moving ahead with the next result, yes, product you know, division you know, that I need not tell you. These are the formulae. The crucial ones are this: z plus z bar, z minus z bar. I hope you know that. And something very crucial, whenever in a question it is stated or claimed that z is purely imaginary, then we say that z is equals to minus z bar. And if it is said that z is purely real, then we say that z is equals to z bar. I hope you'll remember that. And yes, this conjugate can be distributed over addition, subtraction, multiplication, product, power. Yes, it can be done. With that, the next result is this, which we all know, nothing much is needed to be said. With the modulus, you got to be very careful. This property, first of all, that mod z square is zz bar, very prominently and dominantly used in all of questions. And then modulus can be splitted over multiplication or division, but it cannot be splitted over addition or subtraction. But if you wish to split it over addition or subtraction, there comes the triangle inequality. And what is that here? I'll show it to you here. Pay attention to this part. Mod of z1 plus z2. Listen to this part very carefully. It is one of the most crucial parts. Mod of z1 plus z2 is always less than mod of z1 plus mod of z2, and it is always greater than modulus of mod of z1 minus mod of z2, which means modulus of sum or difference, even if it is difference, then also it holds true. Modulus of sum or difference of two complex numbers is always less than the sum of their individual magnitudes, and it is always greater than the difference of their individual magnitudes. They ask a lot of questions based on minimum or maximum value of a complex number, and you solve that by using this inequality. Triangle inequality is called, and please remember that, don't forget that. Although with complex numbers geometry also you solve based questions on minimum and maximum, but this inequality is also very handy and helpful for that concept. Do remember this particular result. If z is a unimodular complex number, which means mod z is 1, which means you can write mod z square to be 1, and we have just discussed mod z square is z bar is equals to 1. So we can always say that z is 1 upon z bar. I hope you wouldn't forget that. Argument based formulae I personally remember as the formula of logarithm. For example, here argument of z1 z2 is argument of z1 plus argument of z2. Argument of z1 upon z2 is argument of z1 minus argument of z2. Argument of z upon z bar is argument of z minus argument of z bar, but argument of z bar is negative of argument of z, so it is 2 times argument of z. Argument of z to the power n is n times argument of z. So I hope this is how you remember formulae based on argument. Will you all remember that? Now we remember one more form, the polar form of a complex number. Euler was a mathematician who proved it. We are not going into the proof, we are discussing the result. So always remember, e to the power iota theta can be written as cos theta plus iota sin theta. And Euler form of a complex number z is given by r e to the power iota theta, where r is the magnitude and theta is the argument of a complex number. I hope you do remember that. Sir, one request after finishing algebra, can you please discuss some small tricks for every chapter? For example, number of reflexive relation. I have shared this video with Ish. After this video, go to our channel. In the videos section, you will find the top 10 most important formulae for JEE April attempt. In that, I have discussed the most important 10 formulae there. You can finish that video, finish this video first and then watch that. It is approximately 10 minutes video. There I have covered this part which you are asking for. That's exactly what I have covered. I hope you understood that. Now moving ahead with this, yes, we do know that here, this you can derive. I'm not discussing the derivation because of the limited time, but you can remember these results. Something very crucial, let's say if there is a complex number and its square root is needed to be brought. Let's say there is a complex number 3 plus 4 iota and you are working out its square root. So its square root is given by, first of all, you put a plus minus because either positive or negative. Then what you do is under root over mod of z plus real of z. So mod of z is 5. So under root over 5 plus 3 divided by 2. And depending on this sign, whatever is the sign before the imaginary part, if it is positive, I'll put a positive here. Then iota times mod of z minus real of z divided by 2. That's the square root of this complex number. That's the short trick you got to apply and find the square root of a complex number through this method. Will you remember that? Now comes de Moivre's theorem. In a nutshell, if I could make you revise that, it's a really simple idea. You just got to remember this. This is something which is highly or prominently used. If you are given cos theta plus iota sin theta, it is basically e to the power iota theta. And if it is raised to the power n, it can be written as e to the power iota n theta as per the identity. And because of that, we can write it as cos n theta plus iota sin n theta. That's the proof here. Everybody got this. But if you get power n as a rational number, just for example 1 by 3, 5 by 6 or something like that, in that case you should remember this cos n theta plus iota sin n theta will be one of those values because nth root has come into picture. Let's say 1 to the power 1 by 3. 1 is the root, omega is the root, omega square is the root. So all the three values you got to attain. And how do we do that? I'll definitely share that in the upcoming slides. Now, coming ahead with that, I hope you know cube roots of unity are 1 omega and omega square. There you know that omega's conjugate is omega square and omega square's conjugate is omega. Omega's reciprocal is omega square and omega square's reciprocal is omega. Not just that, more interesting fact is square root of omega square is omega and square root of omega is omega square. Can you believe that? I hope you're listening and understanding what I'm saying here. So that is how you go ahead with that. Something more important you should remember here is this result. Which result? This one. 1 plus omega to the power r plus omega to the power 2r if you are given, let's say. So this will be either 3 or 0. This will be 3 if r is a multiple of 3. This is not n, this is r. And this will be 0 if r is not a multiple of 3. Are you all listening and understanding? Let's say fifth roots of unity I'm given. Let's say fifth roots of unity are, let's say 1, alpha, beta, gamma and delta. These are the fifth roots of unity. So if I'm doing their sum, which means 1 plus alpha plus beta plus gamma plus delta, but I'm raising them to a certain power. Let's say the power is 22, 22, 22, 22 and 22. So they all are raised to a certain power. So remember, the answer will be either 5 or 0. Now it all depends on whether it will be 0 or 5. How do you decide it? Look at their powers. Is that power a multiple of 5? I think 22 is not a multiple of 5. In that case, answer will be 0. Had this power been like 25, 25, 25, 25, 25, in that case, the answer will be 5. That's how simple it is. Will you remember that result? Questions based on that result are asked. So you got to remember that. I hope you will. Now from here, when I go ahead, yes, when we plot the cube roots of unity, they form an equilateral triangle. If I form the fourth roots of unity, it will be forming a square. If I form the fifth roots of unity, it will be forming a regular pentagon. So they form a regular shape, triangle, quadrilateral, pentagon, depending on the number of roots. With that, these are some more identities which you can simply look at them. This is something which I wanted you to revise. This is something which I wanted you to revise. Resim is saying multiple of 5, not 3, because here these are the fifth roots of unity. These are the fifth roots of unity. So if z to the power 5 is 1, which means z is equals to 1 to the power 1 by 5. So it will have 5 roots, 1, alpha, beta, gamma and delta. In that case, it should be multiple of 5. For omega, it should be multiple of 3. Fourth roots of unity, which means multiple of 4, I'll see. I hope you got that. Now, this is something which I begin with, where we're discussing that if sine is added, sine theta, sine 2 theta, sine 3 theta, where these angles are in AP, then it is given by sine n theta by 2 divided by sine theta by 2 cos n plus 1 by 2 theta. Even if the angles are in sine, previously it was in cos, even if the angles are in sine, then also the formula remains same, sine n theta by 2, sine theta by 2, except for this cos. Now I'll be having a sine here. Will you remember that, all the participants? Now comes the rotation formula, the Conic method. How I personally remember it, I'll simply share this direct formula. Let's say there is a complex number, Z3 Z1. And I have gotten it from Z to Z1. So how am I getting it? Sir, when you rotate Z to Z1, when you rotate Z2 minus Z1 by theta degree in the anti-clockwise direction, and you get Z3 minus Z1, then how do we write it? Please remember, Z3 minus Z1 upon Z2 minus Z1 is given by mod of Z3 minus Z1 upon Z2 minus Z1 times e to the power iota theta. This is how you give or use the rotation formula, the Conic method. Will you remember that, all the participants? Can I move ahead from here? Everybody with me on this? Now, yes, there comes the algebra of the complex numbers. What is it? Pay attention to this here. We know with modulus, we find the distance between the points. So in the complex world, in the Argand plane, let's say there are three complex numbers, Z1, Z2, and Z3. So if I wish to prove that they are collinear, what will I say? The distance between Z1 and Z2, the distance between Z2, Z3, the summation of this should be equal to the distance between Z1 and Z3. Or the other method is area of that triangle should be 0. Or the third method is slope you can take. The slope of Z1, Z2, slope of Z2, Z3, slope of Z1, Z3. It will be same. I hope you are listening and understanding. So now there comes more interesting part. If you are given a circle, if you are given a triangle whose vertices are either vectors ABC or complex numbers Z1, Z2, Z3, then in either case the centroid is given by Z1 plus Z2 plus Z3 by 3 or vector A plus vector B plus vector C by 3. That's something simple and easy. We all know that very clearly. Now, there is something more interesting which you got to remember here. Please remember this as a result. If this is your H, this is G, and this is O. H means the orthocenter, G means the centroid, and O means the circumcenter. Then always remember the centroid divides the orthocenter and circumcenter into the ratio 2:1. That is a formula which you got to keep with yourself. IDJE asks a question on it. They definitely ask a question on it. I hope you'll remember that, all the participants. Now from here, when I move ahead with the quadratic, something you know, sum of the roots, product of the roots. But whenever somebody asks you the difference of the roots, so mod of alpha minus beta is under root d upon mod a. I hope you remember that. No worries with that. I hope you do remember that. Everybody with me on this? From here, when I go ahead, what I see next is converting a quadratic into perfect square, because when you convert a quadratic into perfect square, you get the idea about its vertex, and with that vertex you find its maxima and minima as well. I hope you do remember that. Now here, this is a result which we all know very clearly. Let's say this is a biquadratic, so it will have 4 roots. Let's say the roots are alpha, beta, gamma and delta. So sum of the roots taken one at a time, which is alpha plus beta plus gamma plus delta, will be minus b upon a. Sum of the roots taken two at a time, which is alpha plus beta, beta plus gamma plus delta, and so on, will be given by c upon a. Alternatively, sign changes. Sum of the roots taken 3 at a time, alpha, beta, gamma, alpha, beta, delta, and so on, that summation is minus d upon a. And sum of the roots taken all 4 at a time, that is alpha into beta into gamma into delta, that is e upon a. That same can be followed for a cubic or pentic as well. From here, this is what I was mentioning when one of our students was asking about how do we say that cubic polynomials have range from minus infinity to infinity, and biquadratic or even degree polynomial have a range, not a range from minus infinity to infinity. The logic is really simple. If it is cubic and the coefficient of the highest degree term is positive, it will come from minus infinity and go till infinity. If the coefficient of the highest degree term is negative, it will come from infinity and go till minus infinity. But with biquadratic here, if it is having the coefficient positive, then it will come from infinity, attain a certain substantial minimum value and go back to infinity. If the coefficient of the highest degree term is negative, in that case it will come from minus infinity, go back to minus infinity and attain a certain substantial maximum value. Good, Sarfaraz. Good. Thank you so much for that salute. We really appreciate that. This is something you can see and understand by yourself. I'll move ahead and talk something about sequence and series now. Whenever you see a sequence where sum of n terms is given by an square plus bn, then don't hesitate in saying that, sir, the summation of the sequence is given by an square plus bn, then this will definitely form an AP. If I say that sum of n terms of a sequence is given by 7n square plus, let's say, 3n, then you can unhesitatingly say that, sir, this sequence is going to be an AP. Will you remember that? I hope nobody is with that. I hope you'll remember that. And you can find the first term, second term and all, because when you replace 1 here, you will get S1. S1 means what? Sum of first terms, which is term 1. If you find S2, what is S2? That will be sum of first two terms. So from S2 and S1, I hope you are understanding, S2 minus S1 will give me T2. So from T2, if I subtract T1, I'll get D. So you can find everything related to that. Right, students? Now from here, if I move ahead with this conclusion, if I talk about method of differences, what is method of differences? Please pay attention. Let's say there is a sequence. Let's say term 1 is there, term 2 is there, term 3 is there, and so on. This is majorly used in telescoping sum or with inverse trigonometric function based questions. Then let's say this is a sequence where there is not a much pattern we can see. But let's say if I see the difference here. So first difference between T2 and T1 is A1, between T2 and T3 is A2, let's say between T4 and T3 is A3, and these terms are found to be in AP. So let's say that difference is found to be in AP. In that case, you can write this sequence, the rth term, as AR square plus BR plus C. And then by putting R as 1, 2, 3, you can write T1, T2, T3, and then by comparing the values, you can find ABC. So one of the methods is methods of differences. The other method is generalization. What does it mean? If the difference between the terms is in AP, you can write the general term as AR square plus BR plus C, and by comparing R as 1, 2, 3, you will find three equations, three variables. You can solve them and find capital A, capital B, and capital C, and you can generalize the rth term. Are you listening and understanding what I'm saying here, students? If you are getting it, can we move ahead from here? These are the results which are self-explanatory. If in AP, same term is added, subtracted, multiplied, or divided, then it still remains an AP. If two APs, consecutive terms, are added or subtracted, then also it remains an AP. Raghav is saying, sir, is there any other class, sir? After this class, in the evening at 5, there will be a revision class, and tomorrow also there is a revision class, so don't worry about that. Here, if I talk about GP, we know sum of infinite terms of a GP, there is a standard formula. With that, if I go ahead, if the terms of a GP are multiplied or divided by a non-zero number, then it still remains in a GP. But here, if they are raised to a certain power, or if even their reciprocals are taken, then also it remains into a GP. Something very important and crucial here is that if you have terms in AP, if you have terms in AP, A1, A2, A3 are in GP, let's say A1, A2, A3, and so on are in GP, then if you take their logarithm at any base, then it will be forming an AP. Yes, principle of mathematical induction is removed from JEE Mains. It is not very directly or substantially asked, so you can consider it to be removed from JEE Mains. Now from here, this is a result which you got to remember. Let's say there is a quadratic which has roots A and B. So there is a quadratic which has roots, let's say alpha and beta. So how do we write that quadratic? Sir, we write that quadratic as x square minus sum of the roots plus product of the roots. I hope you remember that. So if I ask you that arithmetic mean of alpha and beta will be given by, let's say, A. Geometric mean of alpha and beta will be, let's say, given by G. So from here, can I not say that alpha plus beta will be 2A and alpha beta will be G square? So with that, will I not be writing the quadratic as x square minus 2ax plus g square? So remember, if you are given arithmetic mean and geometric mean of two numbers, then also you can write the quadratic getting formed by the two numbers. And yes, we know that arithmetic mean is always greater than geometric mean, and geometric mean is always greater than equal to harmonic mean. And if somebody says that m is equal to gm, That equality is possible only when the numbers are same. Everybody listening and understanding, are you all there, getting it clearly? Now from here, let's talk about few more results. We know sum of first n natural numbers n plus 1 by 2. Sum of first n odd numbers is n square. Sum of square of first n natural numbers is n plus 1 2n plus 1 by 6. Sum of cubes of first n natural numbers is n plus 1 by 2 whole square. I hope you do remember that. This is what I was mentioning. Now please try and remember this. If the difference between consecutive terms is NAP, then you can take the nth term or the rth term as AR square plus BR plus C. If the consecutive difference of a sequence is in GP, then you take the rth term, nth term as AR to the power n minus 1 plus Bn plus C, nth term, where R is the common ratio of that GP. Either you apply method of differences method in sequence and series or this short technique, both are useful, but this will get you the answer more quickly. I hope you have used this technique a lot many times. There is one more short technique which you got to remember. What does it say? It simply says this result, that if you have telescoping sum is needed to be done, where this is 1 3 5 7 9 3 5 7 9 and 11, something like that, then do remember this result very clearly, that if this is first of all is an AP, these terms are in AP, where if this is beginning with 1, second term is 3, so it should begin with that second term. If its second term is 5, it should begin with that second term. So this is how it is going, let's say, for a while. I hope you're understanding it, all the participants. Now with that, if I wish to write its sum, remember this is amazingly easy. Its summation is given by, pay attention to that part, this minus this. First of all, do that. So 9 minus 1 is 8. So write that 1 by 8 first of all. Then write the first term and last term. Write the first term and last term. Put a negative sign between them. And do one thing. From the first term, remove the last factor. From the last term, remove the first factor. Which short technique, Rudra Bhatt? The previous one, method of differences, or this one? Which one are you asking? I'll take an example to make you understand this. Let's say there is a sequence. Which sequence shall I take? I'll take an example. Something like, let's say, 7, then what? 19, let's say. Then I'm just writing this sequence 4r square plus 3, right? So when r is 1, it is 4 plus 3, 7. When r is 2, it is 16 plus 3, 19. When r is 3, 9 into 4 is 36, that's 39. When r is 4, that is 16 into 4, 64, plus 3, 67. Let's say this is a sequence. And I don't know its general term. But when I observe this sequence and let's say I notice something, what do I notice? So 7 and 19, the difference is clearly 12. 19 and 39, the difference is clearly 20. 39 and 67, the difference is clearly going to be what? 39, 49, 59, 69. So 28 it will be. So here, the difference which I'm noticing is in AP because this is plus 8, this is plus 8. So this sequence, there is no pattern, but the difference of this sequence is in AP. In that case, what I'm suggesting is, terms is in AP, then this sequence, rth term, can be taken as AR square plus BR plus C, which means first term is 7. So R should be replaced by 1, so it should be A plus B plus C. Second sum is 19, so R should be replaced by 2, which should be R square, which is 2 square, which is 4A plus 2B plus C. Third term is 39, so R should be replaced by 3, so it should be 9A plus 3B plus C. Now these are simple, straightforward 3 equations. You solve these 3 equations, you will find the values of A, B and C. Once you have cracked the values of A, B and C, you can write TR, which will give you the rth term. And by applying summation, you can find the answer. Are you not understanding how interesting, easy and simple this is? Everybody with me on this, getting this idea very clearly. Now from here, when I move ahead, this is the properties of logarithm. We all know that if log x is greater than log y, and if the base is a, so it all depends on the base a. If the base is greater than 1, then x is greater than y. If the base is between 0 to 1, the sign changes. The same logic is applied on the upcoming identities, inequalities as well. I hope you do remember that. Now, these are the formulae of factorial. How do we use them? Some crucial ones, some important ones, if I could highlight. This one. Which one? If x factorial is equal to y factorial, then we all know either x could be y, or x could be 0, y could be 1, or x could be 1, y could be 0. I think I have repeated that only. Which one do you want me to repeat? This one? All I'm saying is that let's say there is a sequence. I'll write a different sequence. Let's say I'll take a different example here. Let's say I'm given a sequence 1 upon, let's say, 3 into 7 into, let's say, 11 into 15, plus, let's say, 1 upon 7 into 11 into 15 into 19, and so on until, let's say, there is a term 3, 7, right? And there is a term ultimately, this is what? Let's say any term I take, 31 plus what? 35, 39 and 43. So this is a sequence. Its sum is needed to be found. So luckily, this is a telescoping sum. So you can solve this question with the help of VN method, telescoping sum. But I am saying in this category of questions, you can apply the direct short technique. What is that short technique? First of all, I can see there is an AP here. Everywhere in these terms, I can see an AP here. Everybody noticing that? Now with that AP coming in picture, I now need to do one thing only. Can you help me the difference here? What is 15 minus 3? 15 minus 3 is 12. So write that 1 by 12 first. Everybody got that? Then write this and that. So this one is 1 by 3, 7, 11. Don't write the last factor in the first term. Minus, write the last term, but don't write the first factor in the last term. So it will be 35, 39 and 43. You solve this and this will be your final answer. It is actually based on telescoping sum, the VN method. Did you get it now, Rudra? Are we clear on this? All the participants? This I think you are clear with. This we have already revised. Now, there is something very crucial you should be keeping with you. I hope you know, if you are asked to find the exponent of a prime, so you simply divide that number by that prime, you take its GIF, then you divide that quotient by that number. For example, 100 when divided by 3, it's 33. 33 by 3 is 11. 11 by 3 is 3. 3 by 3 is 1. So you stop until you achieve 1 and you add all these values. 48 means there will be 3 to the power 48 available in 100 factorial. I hope you all are listening and understanding. All the participants, are we clear on that? Now from here, when I go ahead, there are some more properties. Let's take a break, 15 minutes break. I hope that's fine. Then we'll resume. So it is 12:30. We'll resume at 12:45. I hope you're okay with that. We'll be resuming in 15 minutes. Let me have some water. Let me have some break. We'll continue. Stay there. Great, great, great. Good to have you all. We'll continue in a while. Just give me a moment. All right, so can we resume again? I hope you all are there. Nobody has left. Or if you have left, come back, everyone. I hope this break was sufficient for you all. Let us resume with our discussion. So, we were having the discussion of binomial. So a lot of discussion is going in the chat box. Great. I hope you remember what are we doing? We are revising all the formulae of entire maths for your JEE April attempt. Yes. And after this session, this entire PDF of 200 pages will get uploaded on our WhatsApp channel. If you still haven't followed our WhatsApp channel, you can see the description where you can find the link to follow or see our WhatsApp channel where I'll be sharing this entire PDF which contains all the formulae. Great. So let us get started with this discussion. Here, I hope you know permutation NPR formula. I hope you know this formula where n objects are there, out of which p are alike. Let's say there are 10 objects, out of which first are of the same type, 5. There are 3 of the same type, and there are another 2 of the same type. So they are to be arranged in some linear arrangement. So it will be given by 10 factorial upon 5 into 3 into 2, each with factorial. We know that something really simple and easy. We all know that very clearly. Now there is something very interesting. If n objects, different objects, are to be taken r at a time, when each thing may be repeated any number of times, is n to the power r. What does it mean? Let's say I have 4 fingers in my hand. One is the thumb. So I have 4 fingers, and let's say I have 5 rings. So there are 4 fingers in one of my hands, and I have 5 rings, let's say, for a while. And if I ask you, in how many ways can I have these? Can I have these rings? So I'll simply say one idea, that here any finger can have any number of rings. So let's say I can wear all the 5 rings in one finger. So I'll say I approach the ring and I ask that how many choices do you have? So the first ring says I can go to either finger 1 or finger 2 or finger 3 or finger 4. So ring 1 has 4 choices. Now, if I go back to the second ring, it will also say I have 4 choices, finger 1, finger 2, finger 3 or finger 4. So ring 2 also has 4 choices. So this will give me 4 into 4 into 4. How many times? 5 times. So answer will be 4 to the power 5. Sometimes students get confused, sir, whether it will be 4 to the power 5 or 5 to the power 4. 5 to the power 4 it cannot be, because I cannot ask the finger. Let's say I have approached finger 1 and I ask how many choices do you have. So it may say I can have 0 ring, I can have first ring, second ring, third ring, fourth ring, or 2 rings, or 3 rings, or 4 rings. So there I get stuck, because depending on the choices I'm putting here, then I will have depending choices, remaining choices for this. So a lot of possibilities will get created, which will be very confusing. So wherever you get, wherever you get stuck, wherever you're not able to move ahead because of that constraint, you switch. So instead of asking fingers here, the best advice is you ask the rings, and there you get the final answer. Everybody listening and understanding? From here, when we move ahead, I hope you know that we know the formula. Permutation is always combination first. So when somebody asks you that, sir, out of n objects, r objects are to be chosen and then arranged. So out of n objects, r objects can be chosen in NCR ways, and then those r objects at r places can be arranged in r factorial ways, which is nothing but NPR. That we all know, nothing much is needed to be said there. Here, this is something which you should keep with you at your fingertips. Which one? More importantly, this particular one, where NCX is given as NCY, then we know one of the things could be x and y could be equal, or the other thing could be x plus y could be n, because we know NCR is NCN minus R because of that. Now, one thing which IDJ loves asking is this: NCR plus NCR minus 1 is n plus 1 CR. How do I personally remember it? See, first of all, what should be there is that this n and this n should be same, and this r and this r minus 1 should be the consecutive one. So if something like that is seen by you, then you take the bigger value of this r and r minus 1, and you increase this n by 1. Did you get my point? And through this, you continue with this. And there is one more formula, that NCR is always n by r, n minus 1, CR minus 1. That is also, you use it. In our sessions, also revision sessions, we have used these concepts of formulae a lot many times, right? One more formula, if you can remember, then this will be this: NCR upon NCR minus 1 is n minus r plus 1 upon r. You can directly expand it and get this result, right? I hope you know that formula I need not tell you. NCR is n factorial upon r factorial times n minus r factorial, right? From here, when we go ahead, yes, please remember that result as well, that if n is even, NCR will be greatest for the middlemost value, which is when R is n by 2. But if n is odd, NCR will be greatest for R being either n minus 1 by 2 or n plus 1 by 2. In binomial, they ask you the questions on the greatest coefficient, and there it comes into picture. We all know NC0, NC1, NC2 until NCn. This summation is always 2 to the power n. I hope you haven't forgotten that. But if I take only the even ones, NC0, NC2, NC4, then it will be 2 to the power n upon 2. That is 2 to the power n minus 1. Or even if I take only the odd ones, which is NC1, NC3, NC5 until the last term, then it will also be 2 to the power n upon 2, which is 2 to the power n minus 1. Everybody with me on this? Now, moving ahead from here. Yes. The number of ways of combination of n different things selecting at least one of them is included, which means let's say there are, of course, the condition here is that let's say I have 10 choices in front of me. There are, let's say, 10 pen kept in front of me, pen 1, pen 2, pen 3, pen 10. So these are 10 pen kept in front of me. And how many ways can I have these pens? If any numbers of pen I can have, but I should have at least one pen. So here again the choice remains same. I approach pen 1 and I ask it, how many choices do you have? So it will say either you take me or you don't take me. So with each pen I have two choices. So I'll have total 2 into 2, 10 times 2 to the power 10 choices. But in these 2 to the power 10 choices, there will be one choice where I'm not taking any pen at all. I did not include pen 1, pen 2, pen 3, pen 4, pen 10. All the pens I did not include. So that one case needed to be excluded. So these are the number of ways in which I can have at least one pen out of these 10 pen available for me. I hope you got that result. Any confusion on that? Similarly, when I go ahead, yes, number of divisors, you remember that. That's a very basic formula. Let's say here, there is a number n which is given by 2 cube into 3 to the power 5. And if somebody asks you how many factors it has, this number n, which is 8 into 3 to the power 5, how many factors it has, how many numbers are there which can divide this number. So I'll do nothing, I'll say nothing, I'll say a simple idea that all you need to do is raise this power 3 plus 1. So this power 3 plus 1 is 4, and this power 5 also increased by 1, so 5 plus 1. So that is what? 3 plus 1 is 4, 5 plus 1 is 6, 6 into 4 is 24. So there are 24 numbers, which can divide this number. How simple and easy it is. Why is it happening? The logic is really simple. 2 to the power 3 means 2 has these choices, either 2 to the power 0, 2 to the power 1, 2 to the power 2, or 2 to the power 3. 3 to the power 5 has 6 choices, 3 to the power 0, or 3 to the power 1, or 3 to the power 2, or 3 to the power 5. So these 6 choices, when clubbed with these 4 choices, I get 6 into 4, 24 numbers or choices, which will be dividing this number n. Because any combination of these powers of 2 and these powers of 3 will be dividing 2 cube into 3 to the power 5. I hope you're understanding it very clearly. Now from here, when I go ahead and move ahead with some more conclusions, yes, this is de-arrangement based questions. I hope you remember in JEE Mains, there was a question asked by it, a straightforward question, a one-line question. What was it? There were 5 students and there were 5 roll numbers, and we were asked in how many ways can we make these 5 students sit at those 5 places in such a manner that no student sits at its right place. Question on de-arrangement. So what do we do for de-arrangement? The number of students, which is 5 factorial, then 1 minus 1 by 1 factorial, plus 1 by 2 factorial, minus 1 by 3 factorial, plus 1 by 4 factorial, minus 1 by 5 factorial. You simplify this and you get the answer. So 5 objects at 5 places can be de-arranged. De-arrangement means those 5 objects should not be placed at their respective places. That task can be done in these many ways. First of all, these values you should remember, D1, D2, D3, D4, D5, at least these values you should remember. You can very easily calculate this and you can find the answer. Now, when it comes to division and distribution, what is the meaning of division and distribution? I'll give you a very simple idea. Let's say there are 15 people. There are 15 students, and they are to be divided into 2 groups. Let's say one group has a size 8 and the second group has a size, let's say, 7. So I need to divide these 15 students into 2 groups. So idea is really simple. I'll do it like this: 15 factorial upon 8 factorial into 7 factorial. That's it, the job is done. This is division. But let's say the groups are A and B. So A can be having size 8 or 7, B can also have a size 8 or 7. So this is division. Now I can place these 8 students to either group A or B, and these 7 students to either A or B. So these two groups can be arranged in 2 factorial ways. So this is division and this is distribution. Are you getting it? But let's say if there is this problem. Which problem? Let's say there are 16 students. There are 16 students and they are to be distributed in this manner. 5, 5 and 6. They are to be divided into these 3 groups of 5, 5 and 6. So first of all, the method remains same. 16 factorial divided by 5 factorial into 5 factorial into 6 factorial. But look at this group. This group has been repeated. This group size has been repeated. So this size is getting counted twice or double. So this 5 factorial and 5 factorial will be divided by 2 factorial. Are you understanding this? Are you listening and understanding this clearly? All the participants, everybody with me on this. I hope there is no confusion on whatever is being said. And this is the, again, another division which I'm doing. I hope you're paying attention to this. So this is the division, but this group size appeared twice. So I'm further dividing it by 2 factorial. So here when this division happens, this is 2 factorial by 1. So this is nothing but 16 factorial by, the group size is 5, 5 and 6. And one group size is repeated twice. So I'll further multiply it by 2 factorial because it was actually gotten divided by 2 factorial. Are you listening and understanding this? Let's say one more thing is happening here. What is that thing? Let's say here you are distributing them into 3 groups. Which 3 groups? Let's say they are labeled as A, B and C. So all you got to do is multiply it by 3 factorial. That's the division and distribution. So this was division, and with this 3 factorial, it got distributed into 3 groups. Everybody got this? Are you all there with me? All the participants? That's exactly what is being said here without any confusion. I hope you've gotten this clarity. This part you can understand by yourself. Not much is needed to be done or said. This is how you write the binomial expansion. I think I need not give you much information on that. You got to remember this particular thing that the R plus 1th term of this expansion is always given by NCR, where the expansion is x plus a. So this x to the power n minus r and a to the power r. This is how you write the rth term. So if repeat 3 times and divide by 3 factorial. Yes, Risim. Good. That's a good observation. Now from here, I think we had a discussion on this. This is also we have discussed. This is what? The number of rational terms, the number of irrational terms, the number of integral terms. I hope you remember. We have done a lot of questions on this. Let's say root 3 plus let's say third root of 5 is raised to the power 15. So all you got to do is, let's say I'm asked how many rational terms will be there. So first of all, I'll write the general term. General term means what? TR plus 1. So TR plus 1 is given by what? 15CR. So that will be a rational value. It doesn't matter. But what about that? Apart from that, root 3. Root 3 is what? 3 to the power 1 by 2. So root 3 to the power 15 minus r. So this is 3 to the power 1 by 2 to the power 15 minus r, which is 15 minus r by 2 into third root of 5 to the power r. So this is 5 to the power r by 3. So now I'll be looking, if I want to have an integral value, integer number, I need to ensure that this power and this power should be an integer, which means 15 minus r and r should be divisible by 3. So with hit and trial, you can work it out. I plus F rule for Tarandeep Singh, I have discussed it in yesterday's session. I have given a detailed description on binomial. If you go and watch the revision session which we conducted yesterday, I made you revise 4 to 5 good, decent, really good questions from binomial. And in that revision session, this I plus F rule I have covered in a very comprehensive, in a very detailed manner. So here I may not be able to make you revise it because I have to take a complete question on that, which I have done in the last session. There we are revising the formulae only, but that thing which you are asking for, we made you revise in the yesterday's session. If you watch it, you can see it by yourself. Now there is another set of questions. Let's say there's this question where it asks you that, let's say you are given x plus, let's say x plus any number, let's say 5 to the power, let's say 10 is what you're given. X plus 5 to the power 10 is what you're given, and you're asked that what could be the numerically greatest term in the expansion of this. What could be the numerically greatest term in the expansion of this when let's say x is any value. X is let's say 3 by 2. I hope you understood the question. So first of all, we cannot find the numerically greatest term here, but what we can do is we can take this 5 common from here first, because we can find the numerically greatest term in this 1 plus x by a to the power n. So there, I take this 5 common first. So when I take this 5 common, I will be having 5 to the power 10. And then I'll have this 5 common, which means 1 plus this x I'm writing here. This is x by 5 to the power 10. Now to find the numerically greatest term, there is a short technique. What is that short technique? Pay attention to that part, students. The short technique is really simple. You find m, you work for m. What is m? M is mod x upon a. So mod x. Mod x upon a. Let me calculate mod x upon a somewhere else. Mod x upon a is 3 by 2 upon a. What is a? A is 5 here. I hope you're understanding it. So it is 3 by 10. So it is 3 by 10. So it is 3 by 10 times n plus 1. What is n? Sir, n is 10, so it is n plus 1, which is 11, divided by, again, mod x by a, which is 3 by 10 plus 1. Everybody with me on this? I hope no confusion on that. Here, please remember, modulus I need not put because it is already positive. With that, what do I get? I hope you can see it very clearly. This 3 plus 10 is going to be 13, so it will be 13 by 10. So this 10 and this 10 are vanished. So numerator has 3 into 11. And denominator has 13. 3 into 11 is what? 33 by 13. So 13 into 2 is 26. 13 into 3 is 39. So this will be 2 point something. So m, if it is an integer, my greatest term will be tm and tm plus 1. But since m is not an integer, it is a fraction value. So its GIF is needed to be taken, which means GIF will be 2. So here t 2 plus 1, that is third term, will be the numerically greatest term. Did you all understand the short technique, or shall I give you more clarity on that? Will you remember that by yourself? Now here we have discussed this part. I think the greatest coefficient, we have already discussed this part. This is something you got to remember, as we have already discussed it while we were discussing calculus, that x to the power n minus a to the power n is always divisible by x minus a, whether n is even or odd. Doesn't matter. But x to the power n plus a to the power n is divisible by x plus a only when n is an odd number. Will you remember that? With that, when I go ahead, what I see next is multinomial theorem. I'll simply give you one result. What is that? In multinomial theorem, let's say this is having k terms, x1 plus x2 plus x3 till xk is raised to the power n. Then this expansion will look like what? In this expansion, let's say I am asked the coefficient of x1 to the power alpha, x to the power, x2 to the power alpha 2, x to the power alpha 3 times xk to the power alpha k. This term's coefficient, I hope your understanding, is needed to be figured out. So it will be given by summation n factorial upon alpha 1 factorial, alpha 2 factorial, alpha 3 factorial, and so on until alpha k factorial. Did you all get that? Everybody with me on this? Are you all there? Now, with that, if somebody asks you how many distinct or dissimilar terms will be there in the expansion of this multinomial theorem, x1 plus x2 plus x3 until xk to the power n, then the distinct terms will be n plus k minus 1, ck minus 1. That's again nothing but what? Distributing n identical object among k people. That is exactly what it is. I hope you will remember that. With that, can I move ahead from here? This is the Sarus rule of expanding a determinant. We all know that. We all have discussed it a lot many times. So if there is a determinant a1, b1, c1, a2, b2, c2, a3, b3, c3. So what you do is you repeat the first two rows a1, b1, c1, a2, b2, c2, and then you take the product along the principal diagonal a1, b2, c3, a2, b3, c1, a3, b1, c2, and then you take its sum. That sum, let's say we receive as p. Then you take the product along the non-principal diagonal a3, b2, c1, a1, b3, c2, and a2, b1, c3, and then you do this summation as well, and that you call as n. Then from this sum, if you subtract this sum, you get the value of the determinant. That's the method. I hope you know that without any confusion. You know what are cofactors and minors? I think I need not give you information on that, but one thing you should remember. Let's say there is a determinant made by the cofactors of all the elements. So let's say there was a determinant a11, a12, a21, a22, and I take the cofactors here. So cofactors, let's say I'm denoting by C11, C12, C21, and C22. So let's say this determinant has a value delta, this determinant has a value delta C. Then always remember the result that delta C is always delta to the power n minus 1. If it is a 2 by 2, delta C will be delta to the power 2 minus 1, which is delta. But if it is a 3 by 3 determinant, then delta C will be delta to the power 3 minus 1, which is delta square. Tarandeep Singh, in that case, you are already doing great. You are already doing great, exceptionally well. All I'll say, just don't lose your patience. Stay calm, stay cool. The more calm and composed you are there in the examination hall, the better you'll be performing. That's the only advice I can give you right now at this stage. Here, we have already discussed it when we were discussing vectors in 3D, I think. There we did discuss that this calculus is the part where we discussed it. This ABC, HGF, HGF, this determinant, if it is 0, it will be representing pair of straight lines, otherwise conic. I hope you remember that. And if the lines A1x plus B1y plus C1, A2x plus B2y plus C2, A3x plus B3y plus C3 is 0. And these three lines are concurrent. Concurrent means if all of these three lines are passing through one single point. In that case, this determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 will be 0. I hope you do remember that. Now, regarding Kramer's rule, we all know that if delta is not 0, we'll have unique solutions. If delta is 0 and at least one of them is non-zero, then there are no solutions. And if delta, delta 1, delta 2, delta 3, all of them are 0, then we say infinite solutions. I hope you remember that result. I need not explain that. But if you encounter this kind of a situation where you have these equations like a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, with this I'll say c1z is equal to 0, c2z is equal to 0, and the third equation is a3x plus b3y plus c3z is equal to 0. So of course, one of the solutions of these equations will be what? 0, 0, 0. Because 0, 0, 0, 0, 0, 0, 0, 0, 0 satisfies all these three equations. So that's a trivial solution. But let's say there is a non-trivial solution as well. Non-trivial that apart from 0, 0, 0, there is some other coordinate as well, which is lying in all these three planes. In that case, we say that it has non-trivial solution. So for non-trivial solution, we know determinants of A1, B1, C1, A2, B2, C2, and A3, B3, C3 should be 0. JEE has constantly been asking questions based on that. So remember that you could be facing questions based on that. Some standard expansions I'm showing you. If you can, take a screenshot and keep it saved with you and revise and memorize this particular slide. Whenever you see 1a square, 1b square, 1c square, don't hesitate in replacing it by a minus b, b minus c, c minus a. Directly do that in the examination hall. Don't waste time in expanding or finding this solution. Whenever you see ABC, a square, b square, c square, bc, cab, or 1, 1, 1, a square, b square, c square, a cube, b cube, c cube, then the expansion is a minus b, b minus c, c minus a, and ab plus bc plus ca. If you see ABC, a square, b square, c square, a cube, b cube, c cube, that means here also you get ABC. In that case, the expansion will be ABC, a minus b, b minus c, c minus a. Will you remember that? And the most important one, the most crucial one, this one. If it is cyclic, which means ABC, BCA and CAB, there is CAB written over there if it is not visible. In that case, it is negative of a cube plus b cube plus c cube minus 3ABC. And I hope you do remember this identity which J is in love with. A cube plus b cube plus c cube minus 3abc is given by, I hope you remember, a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca. And we derive one more result from here, which is that if you have the sum of these three numbers to be 0, then we can say this is 0, 0 into anything is 0. Then we can say a cube plus b cube plus c cube minus 3abc is 0, which means it is equal to 3abc. That is something you got to remember. It could be used anywhere in your examination, in any of the questions. So please don't forget that. These are some general expansions which you got to keep with yourself. We all know that for functions, a function can be represented as a sum of an even function and odd function. Similarly, a matrix can also be represented as a sum of a symmetric matrix and a skew symmetric matrix. Symmetric means A plus A transpose by 2. Skew symmetric, A minus A transpose by 2. I hope you know that result without any confusion. And I hope you do remember that result as well, that odd degree skew symmetric matrices will always have the determinant to be 0. I think I cannot. I have taken the screenshot, Shubham, so I won't be able to make you do that. This is the best thing which we can do right now. I'm really sorry for that, but I'll get it typed very soon. So when I conduct the next session, possibly when you might not be there to see this because you would be clearing JEE then and you won't need it anymore, then I'll be conducting it more properly. But right now you have to adjust as per this. I'm really sorry for that, but yes, you got to. This is a slide. Again, take a screenshot of it. I'll not be proving. You take any of these. Let's say I take this one, AB plus BA. And I want to check what will it be. So first of all, what am I given? Let's say A and B are two symmetric matrices, which means A transpose is A, B transpose is B. Now, if I want to talk about AB plus BA, what would it be? I'll say all I need to say is that let's say it is X. So X transpose will be what? AB plus BA transpose. So transpose is something so interesting that it can be distributed over addition, subtraction, product, or division. So here it will be not on division, addition, subtraction, or product. And with the product, the sign reverses. I hope you remember that. So here, this will be 8B transpose plus BA transpose. But with product, the order changes. So it will be B transpose A transpose plus A transpose B transpose. But we know they are the symmetric matrices. So it will be BA plus AB, and BA plus AB was nothing but X. So if I was working on an X transpose and I could get X, which means X is a symmetric matrix. So these results you don't have to remember. You can work it out in this manner like this. I hope you'll do it by yourself. No confusion on that. From here, we know for determinants, let's say there are matrices of the same order. So determinant of A transpose and A will be same. For matrices, if they are getting multiplied and then you take the determinant, or if you take their determinants first and then you multiply, get the same result. I hope you remember skew symmetric matrix of odd order. The determinant is 0. And yes, this is something which JEE uses a lot. Determinant of Ka, where K is a scalar, will be K to the power n times determinant of A. You use it a lot, many times in a lot of questions. Please don't forget that. This is something which is very highly used. I will remember that. From here, when I go ahead, this is the most important slide of your entire discussion. At least 2 questions you'll be seeing from this slide in your JEE Mains paper. And with those 2 questions, plus 8 marks you're going to get. Take a screenshot, keep it saved, and revise it thoroughly. I'll absolutely, definitely make you go through this. First one, we know that this lays the foundation for the inverse of A, because adjoint of A into A upon determinant of A is identity matrix. So the matrix of A has its inverse defined as adjoint of A upon determinant of A. And for its inverse to exist, determinant of A should be non-zero, which means if the matrix is non-singular, then only it's invertible, which means its inverse exists. Second condition, if you have determinant of adjoint of adjoint of adjoint, where adjoint is appearing m times, it is given by determinant of A to the power n minus 1, where n is what? The order of the matrix raised to the power m. This is not determinant of A to the power n minus 1 whole raised to the power m. No, it is determinant of A to the power n minus m, and this n minus m is raised to the power n. This is something which is definitely going to be there in your paper. In a short manner, they will be asking you a question. Surely it is going to be there in your paper. They are asking questions on it. And of course, these are the ones adjoint of A. You use it a lot many times. Determinant of A to the power n minus 2 times matrix A. Adjoint of K to the power n minus 1, adjoint of A. Don't confuse it with this. Determinant of K to the power Ka, that is K to the power n times determinant of A. That's different. This is adjoint of Ka. So this is K to the power n minus 1, adjoint of A. They are different. A inverse we know. Inverse for product of matrices, the order reverses. We all know that. Moving ahead, probability, you know this. Odds in favor, odds against. Nothing huge, nothing much is needed to be discussed there. Bayes theorem we all know. Tree structure you make. Principle of inclusion and exclusion need not be covered here. I think this is something which are the standard formulae. But yes, when probability distribution is given, let's say for a random variable x, 0, 1, 2, 3, r is given, and the probability is given for that. So we know that here, I hope you know that, where P shows you the success of one probability, Q is the success of non-success of that probability. So P is 1 minus Q. And n trials are being done. So out of n trials, 1 success is taken, then NC1, P to the power 1, Q to the power n minus 1. If exactly 2 successes are needed, where x is 2, so NC2, 2 success, P square, Q to the power n minus 2, and so on. So in this probability distribution, few things are there, which means whenever somebody talks about mean, all you do is NP. Number of trials into success probability, that is P, will give you the mean. Then the variance is given by NPQ. I hope you remember that. And standard deviation which is the square root of variance, I hope you remember, is given by under root NPQ. I hope you do remember that without any confusion. I hope there is a crystal clear clarity on that. Everybody with me on this, all the participants. Now here, let's go ahead with this next. This is something somebody, I think it was Rudra, who was asking, sir, what about 1-1 function, 1-1 onto many one? So this gives you the number of 1-1 mappings, sorry, 1-1, 1-1 onto, and this is many one. So if probability based questions is there, you can solve it like this. All the participants who want the PDF of this session, don't worry, we'll be sharing this entire 200 pages PDF of this entire mathematics revision session on our WhatsApp channel. You can follow us, you can follow the WhatsApp channel by clicking on the link given in the description, where it will redirect you to our WhatsApp channel. Yes, the link is given. You can have this PDF as it is. Yes. Now moving ahead, there I have given you the detail of how a cards is played. This is D arrangement. When we discussed 5 students, 5 roll numbers, they are made to sit like this, that no student sits at its right place, which means D5 it was. So these values you should keep, D1, D2, D3, D4, D5. These values you must by heart. Please remember that. Don't forget that. Okay, great. Moving ahead with that, the second last part, trigonometry, then coordinate geometry. In Trigo, I won't be explaining much. I'll be showing you the slides and we'll be going ahead with that. These are the standard 3 identities which you have studied in 10th standard as well. The conversion formula, which we all know, nothing much is needed to be said. You just create a right angle triangle, you write a theta, you take the ratio, let's say this is A and B, so you define the hypotenuse and then you take the ratio accordingly. We all know all positive, sine and cos, tan and cot, cos and sec. If you are moving from y-axis, the ratio changes, sine to cos, sec to cosec, and tan to cot. But if you're moving from x-axis, then the ratio doesn't change. I hope that conversion you know, nothing much is needed to be said there. Formula you should know, that when do you see sin x to be 0? So 0, pi, 2 pi, there you see sin x to be 0. When do you see cos x to be 0? Sir, at all the odd multiples of pi by 2. Tan x is 0 again at 0, pi, 2 pi. So this is how you see the graphs. They give you more clarity because graphs are needed. With the graphs, you solve a lot of questions based on trigonometric equations. With the graphs, you may sometimes get the number of solutions very quickly even without solving the whole question. We did such questions previously in last day's session as well. These are the identities. This is something very important. Students, don't study it. Please look at this. Very simple, very easy to remember. Sin A plus B, sin A minus B. It is like that A plus B into A minus B, A square minus B square. So sin square A minus sin square B. But if it is cos A plus B into cos A minus B, in that case, it is cos square A minus sin square B, or cos square B minus sin square A. Remember that. Will you? Second is product to sum. That is again sin C plus sin D formula, or simple one, sin A plus B we know, sin A minus B we know. So mentally you can add it and you get the final results. But you should be careful with this fourth result, where it is cos A minus B minus cos A plus B, which gives you 2 sin A sin B. I hope you are comfortably understanding that. Then of course these ones, which are again nothing but what? Sin C plus sin D, sum into product. We know them, we have been discussing them, so I think I need not explain them. These ones I have explained while we were discussing calculus, sin 3a formula, cos 3a, tan 3a. And the most important ones are these ones, because direct questions were asked by JEE Mains on these formulae. I hope you do remember that. Something which JEE uses in integration a lot is this one, that 1 plus cos 2a is replaced by 2 cos square a, or 2 cos square a I could be replacing by 1 plus cos 2a depending on the requirement. And sin square a I could be replacing by 1 minus cos 2a by 2 as per the requirement of the question. So these formulae you got to remember. Don't forget them. They are very crucial one. This is something if you could memorize, and if a question comes on these half angle formulae 7.5, 15 degree or 18 degree, trust me, you will get the answer very quickly. There have been questions like that, cosec 18 degree is a root of which quadratic equation? So if you know sine 18 degree, you write its reciprocal and there you get the answer. Definitely famous user, definitely will try to be there. But here if I continue with my discussion, if I could give you some crucial information here, I'll ask you to remember at least 15 degree, 18 degree and 36 degree. Because with 15 degree, you can work out 75 degree. And at least these 3 values you should keep with yourself. Same you should keep with cos as well. At least these 3 values you should keep with yourself. And if you remember it for sine and cos, I think you will work out for tan as well. But at least these 6 values which I have highlighted, should be remembered and memorized by you. Please do that. Don't skip it. Then moving ahead with this, a sine theta plus b cos theta. We all know it is negative of under root over a square plus b square to positive of under root over a square plus b square. That's the range of your expression a sine theta plus b cos theta. That is what is used. JEE has asked direct question based on it. It has given you an expression and it has asked you how many integral values are there, which are there in its range. Direct numerical questions were there. Integer type questions were there. So I hope you wouldn't forget that. From here, the general solutions we have discussed. When sine theta is 0, cos theta is 0, tan theta is 0, we have already told you that if you remember the graphs, you can derive these direct results very quickly. And yes, when sine theta is equals to sine alpha, it is n pi plus minus 1 to the power n times alpha. When cos theta is equals to cos alpha, theta is 2n pi plus minus alpha. When tan theta is equals to tan alpha, it is n pi plus alpha. Even if you remember these results, they are sufficient because as they say, trigonometric equations is omitted, but it is not, it is there. I can show you the questions in the January attempt as well. Fresh, raw, absolutely fresh questions asked by JEE Mains. And whenever you see sine square theta to be sine square alpha or cos square theta to be cos square alpha or tan square theta to be tan square alpha, then the general solution is simple, n pi plus minus alpha. These results you should remember. For inverse trigonometric functions, yes, these are the domains and these are the range. To make them exist, we restrict them into a principal domain and principal range. And with that, these are some identities. There are some mistakes students commit. Sine inverse sine theta is not always theta. It is theta if theta is from minus pi by 2 to pi by 2. But what if it is not between then? Then in that case, you use the cyclicity, periodicity. You make it lie between minus pi by 2 to pi by 2 and then you nullify sine inverse by sine. I hope you remember that. Just give me a moment, students. Green tea, green tea. Green tea. Now, moving ahead with this, I hope you have seen all of these. They are very basic and understandable. Similarly, students commit a mistake here that whenever they see sine inverse of sine inverse x, they nullify it and they write x. No, that's wrong. Here, this x is the value. So it should lie between minus 1 and 1. If let's say somebody says sine inverse of 5, then you wouldn't say it will be 5. That doesn't exist because sine inverse 5 is not defined. The x should lie between minus 1 and 1. Are you listening and understanding this part? The same is true for the other as well. You got to take care of the principal domain. This I personally remember by this. I treat sine inverse and tan inverse as odd functions. So sine inverse of minus x and tan inverse of minus x will be minus of sine inverse x and minus of tan inverse x. But for cos inverse of minus x, it is pi minus cos inverse x. The same will be true for their reciprocals as well. Will you remember that? I hope there is no confusion on that. I hope there is no doubt or queries or concerns with that. These are some formulae. Again, there is a catch. There was a direct question asked by JEE Mains that sine inverse x plus cos inverse x is pi by 2. Not for all x. This will be pi by 2 only when x is from minus 1 to 1. So these basics and these nuances you should be aware of. If you don't take care of these minute details, you could be committing errors or mistakes. Something really simple, if you could remember, only one formula from ITF, it will be this. This is used in telescoping sum, which means sequence and series. This is used with method of differences, and they merge it with a lot of other places as well. So tan inverse x plus tan inverse y or tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus xy. I hope you will remember that. Please do that. Please don't forget that. This is something you got to keep with yourself. Now from here, when I go ahead, what do I see next is another conclusion, the final chapter. The way Aditya Dhar makes his movies, we are also coming up with chapters. The first chapter was calculus. The second chapter was, I think, algebra. Third chapter was, I think, vectors in 3D. I think I have swapped it. And fourth chapter was trigonometry, and the fifth chapter is coordinate geometry. I have a niece, my sister's daughter. I asked her to record a short for me, and when I gave her the script, trigonometry, she pronounced as trigonometry. I really laughed a lot. So trigonometry it is not, but yes, it is interesting that how these kids see these words and spellings, right? Trigonometry. Now here, coordinate geometry, our final section, final chapter, the climax is here. With this, we'll be concluding this. So possibly within next 10 to 15 minutes, we'll be calling it a day. Remember, we are making you revise all the formulae of your entire mathematics. And with that, all of these formulae will be given and delivered to you on our WhatsApp channel as well. You can follow it by seeing the description given in the link. Oh, sorry, link given in the description. Now, coordinate geometry, we know the ratio formula. I hope you know that. So it will be m times this plus n times this divided by m plus n. Internally, if externally, m times this minus n times this upon m minus n, right? From here, if I talk about this I have already given you that if there is A and B line segment and this line ax plus by plus c divides it into lambda is to 1, then that ratio will be negative of power of x1 comma y1 with respect to this line upon power of this point with respect to this line. Doubt session will be conducted very soon. I'll have a word with the YT team and we'll conduct it for all the 3 faculties, for all the 3 subjects. I hope you are understanding it. And if this ratio is finally found to be negative, the division could have been external. If the ratio is finally found to be positive, the division could have been internal. I hope you all are listening and understanding. This stair method, as we have just discussed, if you are given a polynomial, just ensure that cyclicity is there. You're not abruptly jumping from here and there. There is a pentagon. There is a pentagon and you are asked to write its area. Then you follow a certain order. Either you go from A to B, then C, then D or E, or you from A to E, then D, then C, then B, and then A. You cannot jump abruptly. It means from A to C, then C to E, then E to D, and then D to B. No, you cannot do that. So you take x1, y1, x2, y2, x3, y3 until x5, y5, and then again you write x1, y1. There you end. Modulus of half. So stair is expanded like this into this, minus this into this, plus this into this, minus this into this. So when you go like this, you add it. When you go like this, you subtract it. And without even determinants, you can find out the area of a polygon. Mostly, they ask you questions from triangle only. If you are given midpoints, this is something really simple. I'll simply put it like this. Let's say if this is a triangle, somewhat like this. There is this point 3, 1. I'm really sorry. There is this point, let's say 3. I'm randomly taking, this could be true or not. I'm just randomly taking these midpoints. Let's say this point is 5, 7. These are the midpoints. Midpoints means this is the midpoint of this side, and this is the midpoint of this side. And let's say if I want to talk about these points, so the idea is really simple. Don't use much logic here. The idea is really simple. What you do is, to get coordinates of C, add this and this and then subtract this. What does it mean? 5 plus 2, 7. 7 minus 3 is 4, so this will be 4. 7 plus 3 is 10. 10 minus 1 is 9, so this will be 4, 9. Did you get that? Let me give you one more example. Then you tell me what will be the coordinates of A. Give me that. For B, it will be this plus this minus this, which means 3 plus 2, 5, minus 5, that is 0. 1 plus 3, 4, 4 minus 7, that is minus 3. Can you help me with A? Write it in the comment box. What do you think? What could be the coordinates of A? I hope you are creating the logic. This plus this minus this. So how many of you got this? 5 plus 3, 8. 8 minus 2 is 6. 7 plus 1, 8. 8 minus 3 is 5. How many of you got 6, 5? Do write in the comment box. Now, from here, when I move ahead with the next, we know that the direct formula, I hope you remember this result, that circumcenter, incenter, orthocenter, what are they? For example, here, if I ask you, there is a triangle. So if you draw all the medians, so where medians intersect, the centroid gets created, usually denoted by G. If you draw all the perpendicular bisectors, I hope you understand perpendicular bisectors means this. These are perpendicular bisectors. So when you draw the perpendicular bisectors, they give you the circumcenter. Let's denote it by O. Circumcenter means a circle which is passing through all the 3 vertices will be having center this O, which means it will be equidistant from this, and from this. This means it will be the circumradius. Everybody getting it? What is in center? If you draw the angle bisectors, I hope you understand angle bisector. Angle bisector means this angle bisector, this angle bisector. So this will be the in center, usually denoted by I, which means if you draw a circle touching all the sides, then this perpendicular distance, this perpendicular distance, this perpendicular distance, all of them will be same. So this will be the in radius here. And with altitudes, let's say there is a triangle, I drop a perpendicular altitude here, I drop a perpendicular altitude here. This is the orthocenter. So these are 4 types of centers. Now in the examination hall, you could be asked any of these. Simply remember this formula, M1, M2, M3 with x1, x2, x3 and M1 plus M2 plus M3. Now M1, M2, M3 changes. For centroid, m1, m2, m3 will be 1, which means x1 plus x2 plus x3 by 1 plus 1 plus 1. That's centroid. For in center, it will be sine A x1, sine B x2, sine C x3 upon sine A, sine B, sine C. What is sine A, sine B, sine C? A, B, C are your angles of those vertices. Sine A, sine B, sine C are those ratios. ONGC rule, great, perfect. I'll show you the ONGC rule as well. But 9-point circle is not very usually asked there. Rather, I'll give you a better result, which is mostly asked. 9-point circle is not, they cover in JEE Mains mostly. But if you ask me, HGO, where H is the orthocenter, G is the centroid, and O is the circumcenter, then they are always collinear, and this is divided into 2:1. Please remember that. And here, there is a catch that for isosceles triangle, all of them are coinciding, so then there will be no collinearity, they'll coincide. I hope you got that. From here, when I move ahead, this is what we have discussed. Take a screenshot of it. I hope you are aware of this as well. Just let me have some water. This is something which is more interesting. If you know the slopes of two lines, the acute angle between them is given by theta, tan inverse, modulus of m1 minus m2 upon 1 plus m2. Parametrically, if there is a line which is having, let's say, slope tan theta, so I write it as x minus x1 upon cos theta, y minus y1 upon sin theta is equals to r. So any point on this line, in 3D also we have done it. So any point on this line is given by x1 plus r cos theta, y1 plus r sin theta. If it is going above on the right hand side, r is taken positively. If it is going below on the left hand side, r is taken negatively. Do you all remember that? From here, when I go ahead, this is what we know. Position of a point with respect to the line. If the point lies on the same side, if the 2 points lies on the same side of the line, they'll give the same power, which means the sign of the power will be same. Either both will be positive or both will be negative. Perpendicular distance of a point from a line, we know that power of a point in that line divided by under root over a square plus b square. Feet of a point and mirror image of a point, we know if it is feet, it is minus. If it is mirror image, you use -2. Just look at this formula, you will realize by yourself. I think I need not give you more information on that. Circle, we know is standard. This is your standard circle. Its center is minus g comma minus f. Its radius is under root over g square plus f square minus c. I hope that's easy, simple, understandable. Here's something very interesting you got to remember, diametric form. If extremes of the diameter of a circle are x1, y1 and x2, y2, then it is given by this formula. And if you see two quadratics, one quadratic in x, one quadratic in y, that also gives you the equation of a circle, where it will be x square plus y square minus x times sum of the abscissae x1 plus x2 minus y times the sum of the ordinates plus product of the abscissae, which is x1, x2 plus product of the ordinates. Are you listening what I'm saying? I am saying, let's say there is a quadratic x square minus 3x plus 2s, something like that, and then y square plus something plus something. So those quadratics, when merged, they are also the diametric form of a straight line, of a circle. Everybody listening and understanding, are you all there? We are about to finish this in very soon. Now, whenever there is a point, whether inside or outside the circle, inside or outside or on the circle, it doesn't matter. So its minimum distance from the circle is given by this. When you join it with the center and when you subtract the radius, I hope you remember, this will give you the minimum distance, this. And the maximum distance will be when you extend it here. This distance, when you CP is added with this radius r, this gives you the maximum distance. So CP minus r will be the minimum distance and CP plus R will be the maximum distance. We all know that. If you draw a tangent to a circle from an external point, let's say this is an external point, from this a tangent is drawn. So let's say this is a point x1 comma y1. This is the equation of the circle, which is s is equal to 0. So if I do under root s1, which means I'll get this length, which is called the length of the tangent. I hope everybody is there with me on this. No confusion on that. From here, the next conclusion is chord of contact is always given by T is equal to S1. I hope we are correct. Sorry, I'm really sorry. Let me correct it. If you have a circle whose chords equation you are writing, but its midpoint is given, in that case, this equation of this chord is given by T is equal to S1. So what is T? T, I hope you remember, x square by xx1, y square by y1, x by x plus x1 by 2, y by y plus y1 2, and s1 is nothing but power of that point with respect to that circle. Everybody with me on this, all the participants. So T is equal to S1 gives you the equation of the chord which is bisected at a point. But equation of a chord of equation of the chord of contact. So I hope you remember chord of contact means what? Let's say there is this circle. From an external point, I can draw two tangents, a pair of tangents, and where they connect, this is the chord of contact. I hope you remember that. So this chord of contact is given by t is equal to 0. So this chord of contact is given by t is equal to 0. I hope you know what is t, what is s1, what is s. Now these are the different cases when C1, C2, the distance between their centers is more than sum of their radii. They are isolated. If it is equal, they touch each other externally. If the distance between the centers is less than the sum of the radii but more than the difference of the radii, then they intersect at two distinct points. If distance between the centers is equal to the difference of the radii, then they touch each other internally. And if this distance between the center is less than the difference between the radii, then one of the circles lies inside the other circle. And we can talk about the number of common tangents as well. 4, 3, 2, 1, 0. You all can see it. So there are two types of common tangents, direct common tangent and transverse common tangent. I hope you remember that. There is formula as well for direct common tangent and transverse common tangent. Now let's talk about this part, which we have discussed, that this determinant ABC, HGF, if it is not found to be 0, if it is 0, pair of straight lines, but if it is not found to be 0, it represents the conic, circle, parabola, ellipse or hyperbola. So if you see eccentricity to be 1, which means h square to be AB, where delta is not 0, of course, it will be a parabola. If h square is less than AB, ellipse. If h square is greater than AB, hyperbola. If h square is greater than AB, but if a plus b is 0, then rectangular hyperbola. If you could remember this, you could solve questions based on that. Will you? Now there is another conclusion. If I talk about parabola, let me give you a crystal clear clarity. This is a parabola which has focus. This is a parabola, y square is equals to 4ax. So it is having its vertex at 0, 0. Its directrix will be x is equal to minus a. Its focus will be a, 0. Any point parametrically can be taken as 80 square, 280. Its latus rectum will be this. I hope you are understanding. Any line, this will be L actually. This will be LL dash. So this will be the latus rectum. Length is 4a. I hope you are listening and understanding. So for parabola, we know PS is equals to PM because eccentricity is 1. So PS upon PM is E. But for parabola, E is 1. So for parabola, PS is always PM. What is PS? Point on parabola, its distance from focus is equal to perpendicular distance of that point from its directress. I hope everybody is listening and understanding, all the participants. Now from here, when I go ahead, we talk about few more conclusions. Equations of parabola. I'll talk about this one only. So if the parabola is given by y square is equals to 4x. So if I am writing the equation of the tangent in slow form, it is given by y is equals to mx plus a by m, where point of contact is given by a by m square, 2a by m, and condition for tangency for a parabola is given by c is equals to a by m. Please remember that result. I'm giving this result for the standard parabola. Do remember it. Other results are also there in parametric form as well, but if you remember it in the slow form also, that is also fine. Moving ahead with this, we have discussed the property of reflection of parabola as well. So if there is a ray coming from infinity and if it touches the surface of the parabola, it passes through the focus of the parabola. And if there is a ray coming from the focus of the parabola and it touches the surface of the parabola, then it gets reflected and it goes to the infinity and it stays parallel to the axis of the parabola. I hope you know that, the basic standard property, reflection property of a parabola. Now if I talk about ellipse, we know a few things. Ellipse, if it is a standard ellipse, x square upon a square plus y square upon b square is equals to 1, where a is greater than b. Then x-axis will be the major axis, y-axis will be the minor axis. The major axis will be having length 2a. I hope you know that. This length will be 2a. This length over here will be 2a. I hope you know that. This length over here will be 2b. Why? Because this will be a, 0. This will be minus a, 0. This will be 0, b. This will be 0, minus b. The same formula we'll be using for hyperbola as well. So eccentricity is E. I hope you remember, for ellipse, eccentricity is given by E square, 1 minus b square by a square. B square by a square because b is less than a, is smaller upon greater. Ellipse has eccentricity less than 1. So it is 1 minus b square by a square. For hyperbola, it will be 1 plus b square by a square. Now if I get back to the discussion we were having, foci are ae, 0 minus ae, 0. The same will be for hyperbola. The directrices are x is equal to a by e and x is equals to minus a by e. The same will be there for hyperbola. I hope nothing much is needed to be said. Yes, there are Latus rectum, they have the length 2b square by a. Parametrically, any point if you want to take, you can take it as a cos theta comma b sin theta. I hope you remember that very clearly. That is something I think we have discussed. So if it is a vertical ellipse, in that case, a will be less than b. In that case, major axis will be y-axis, minor axis will be x-axis. Are you all listening and understanding, everyone, all the participants? Now from here, when I talk about hyperbola, same result, same discussion. Again, hyperbola's equation is given by what? Standard equation x square by a square minus y square by b square is equal to 1, where a and b, the value doesn't matter. All you need to understand is eccentricity here is given by 1 plus b square by a square. If there was minus 1 here, it will be 1 plus a square by b square. It rotates. Now, if I talk again about these results which we have just discussing, again, foci is minus ae comma 0, ae comma 0. The directrices are x is equals to minus a by e, x is equals to ae. The length of latus rectum is again 2b square by a. I hope you are understanding it very clearly. And apart from that, yes, ps upon pm is always eccentricity, which is greater than 1 for hyperbola. For ellipse, it is less than 1. And I would say again, this is your transverse axis which has length 2a. This is your conjugate axis which has length 2b. So this is, I think, all when I talk about the hyperbola. But there comes rectangular hyperbola. The standard version of it is xy is equals to c square. Why are we discussing this? Because this rectangular hyperbola based questions are there in definite integration, where you are asked to deal with area under the curve. So if you could remember a few details. First of all, whenever you draw it, it is drawn like this: first quadrant and third quadrant. I hope you remember it. And then these are the few results which you can look and understand by yourself. But remember this is how the rectangular hyperbola is drawn. This is the QR code by scanning which you can follow our WhatsApp channel. Why am I asking you to do so? If you want to have this PDF of 200 pages, 205 pages, which includes all the formulae of your entire JEE mathematics, you can follow our WhatsApp channel. The QR code is shown on the screen. This will redirect to your WhatsApp channel, where I'm going to share the PDF of this entire session. The entire session's PDF, all the maths formulae will be sharing there on our WhatsApp channel. Yes. For the April attempt of JEE 2026, all the formulae are going to be there. If you want to revise it through this PDF, or if you want to keep it saved for the last minute revision, or if you want to watch this entire video at 2x before your examination, yes. So this is that, what should I say? Khajana, I must say, you can use, you should use, and with that, I am calling it a day. So I hope you must have learned and enjoyed a lot. With that, can we call it a day? I hope you all are there listening, watching, and understanding. With that, I am calling it a day. Thank you so much. You have been a great audience. Take a good care of yourself. Good day, everyone.